Welcome. Are we live? Let me see if this little bad boy is up and running. Oh, yep, it is. And you can hear me. Fantastic. Let's close that on down and let's get to it. If I know it's been a little bit. If you haven't been in the Discord, I have been active. There's my phone sabotaging me as usual with the Twitch notification. Thanks, Twitch. Always a good distraction. If you haven't been in the Discord, I have been active. I've been trying to stream. I'm super busy, so it's rough. But I have time right now, so we're streaming right now. Also, if you haven't been following, there's a large PR happening. There's a large PR. Isidiush says, hey, Highlands. What's up, Isidiush? How's it going? It's so good to see you again. Welcome back. Welcome back. Anyway, I got carried away and I wrote 10,000 lines of code. It's been like a month. I haven't had like time to stream it. I've had like 30 minutes here and 30 minutes there, and I've made progress on this giant new topic, instruction selection, and also object files, which turned out to be a small part of this. But this was the easy part. This is the hard part. Anyway, and there's more. Isdish says, I missed streams. I don't know if you did. It's been 3 weeks. It's been a while. I feel bad. I've streamed as much as possible. Time goes by fast, sadly. Anyway, there's, as you may notice, 200 commits because it's been a month on this. It's been over a month now on this PR, and this PR actually started as just object files, and we worked on it at the end of when we streamed last. And then I've just kind of, I've had time to put in little bits, and I've put in 100 and something little bits, and now there's quite a bit of things. But it's going well. One thing that I did do, which I think will help everybody, is I've created a document that is a high-level overview of how the compiler works, which I think anybody wanting to get into the compiler, this will help them a lot. Or at least I hope so. Or anyone wanting to write their own. So this is what it looks like. I am going to zoom in a little, if I can. And then pop this bad boy down. Perfect. Okay, so basically, as you can see, we start with source code. And source code is, as we all know, Intercept, our favorite language. And here, let me load the file first so it'll look good. Perfect. And then I'm going to load the other file while I'm at it that I need to load. And now we can open some source code. For example, this is rule 110. As you can see, we can define functions that take parameters and optionally return things or don't. We have all these things that we can do. We can define variables, and in fact, all this could be simplified now. We don't need this explicit typing, really. We could just do this, but it's probably a good idea to keep the call count explicitly typed. And in fact, it's probably a good candidate for arbitrary integer types, but we'll get there. But this is Intercept. This is that first, I always get confused between Alt-Tab and Control-X-B. Isidiush says, holy shit, 10k lines. Yes. Yes. We got at least 10k. I made a joke a few weeks ago where I was like, oh, it's going to be 10k, and then it's actually 10k. No good Nick, follow, thank you so much. My hands smell like shoe goo. Okay. This graph might be a little confusing, but I promise it's not too bad. Then we have the front end of the compiler. This is found basically in parser.c, but also ast.c, but you'll see how it goes. So as you can see, sequence of tokens. What do we have? We have a token struct. So this is exactly what the implementation, right? And this token basically just has a type, a location, which is like a, we can look at it if you want, but it's basically just a struct that contains a beginning and an end for within a file. So you can tell, oh, this is on line, blah, blah, blah. Xcoding and no good neck. No good neck. No good Nick. Thank you so much. Hello. Thank you so much for tuning in. I'm glad you have joined the exclusive club of Lenser viewers right now. It's been 3 weeks since I've streamed, so I'm a little rusty. I'll get better, I promise. I gotta move this this chat better where I can see it. There we go. Okay. Anyway, we have a token. We split the source code into a sequence of tokens. We then go into the AST, which is, again, that's in AST.C and H. And this is basically a tree of nodes which contain data based on the syntax of the program. So we have like, oh, this is a function, this is a variable declaration, this is an if statement, a while loop, this is a block, right? Like braces within a block, a scope in C. And then we also have types defined in here because types are just AST nodes, but fancy. And then also symbols, but we don't need to worry about that. And we use token types for more than one thing, so they're defined here. Don't worry about any of this. All of these token types represent anything that may show up in the file. As you can imagine, like 1 plus 1 is just going to be a number plus number, right? And when we get that sequence of tokens in the parser, then we can tell, okay, we've parsed 3 tokens and it created this AST node from it. So, by the way, this is the Lexer. It's what splits things into tokens. I don't think we need to go into the implementation too bad. And it's not a good implementation. It really should be based on code points, but it's based on characters. And well, don't worry about it. We'll get there. We'll get there. It's not a priority right now to accept UTF-8 function names or anything. Anywho, we have the Lexer split it into tokens, which we can see in this Lex full bad boy, in which you just call next token. That's what it's called in this implementation. Let's find the definition, shall we? And sorry, it says, I see someone forgot to ping Discord. Ooh. Nah. I was just testing you guys. It's been 3 weeks. Okay, what are we doing? Machine code, let's just go compiler part 55. 56. Machine code go burr. Don't forget the ping. Isidiush says the cover up. Yeah, we were actually just having a secret party without you guys. We were having fun. We knew what we were doing. Yeah, we talked about it, totally. The ping has went out. 5 minutes too late. It's not too bad, though. Not too bad. We were just going over the new compilation overview document, and we got to the sequence of tokens, and then we're in the parser, and a next token, basically this returns the next token in the sequence of tokens from the source code, right? And how it does that is it just lexes a character at a time, and then if it's end of file, you'd return end of file. If it's left paren, you return left paren. It's not complicated. The most complicated part here is advancing the parser state, which is not complicated. It's one function call, right? And you can see it gets more complicated if you want like colon equals. We could probably write a trie for this. A prefix tree. I can't speak today. Don't worry about it. But this is fine. It's really not going to be a difference in performance. It's just going to be a difference in code length. Anywho, with this sequence of tokens, we just call next token every time we want one in the parser. You can see in consume with the expected blah but got blah, right? Or just directly, like when we're parsing an if expression and we go, oh, we found an else keyword, skip it, give me the next token. And then we parse expression, which will give us even more things. Sraid says this is basically a try already, just manually. Exactly. And there are no failure paths anyway. I would hope not. But yeah, it would just be a difference in like defining the grammar, because defining the grammar would be like new operator colon equals. You know what I mean? Or like triad operators. I don't know. It's something to think about. And then, or this could be a struct with like the token type too. That's probably what it would be. Because that would be like the match that it stores. I don't know. It's really, you're right. There is no difference in like performance or anything. It would just be in code size, because we would have like one function that just generically loops over the try and reports matches versus, and then we could just declaratively define the grammar. Isidiush says, do we match every token individually? Yeah, there's not that many. You should only write the tokens that you need. But for example, if we go to next token, you can see that we literally just switch on the character. If it's 0, we do end file, left paren, and there's a lot of them here, right? Every single one that we want to handle. So shift right, greater than or equal, greater than. Sorry, it says, that's typically called a Lexer generator. Well, we'll make one of those. That way anybody who wants to add a language to the Intercept compiler, it's easy. We'll do it. But yeah, every token is matched individually. You can see single quotes and double quotes. And we parse or lex a string, etc. And then if it's anything else, we assume it's a number or identifier. We have to get better at this, because if we're going to handle Unicode code points, we don't like want anything else, but, or maybe we do. Maybe we want anything that's not recognized, just treat it as a regular code point that adds to an identifier or number. I don't know. Not a bad idea. Sorry, it says GNU flex moment. Basically. I mean, I basically wrote GNU BFD, the very beginnings of it, with the generic object file. So it says Bison is, oh, Flex isn't even part of GNU, Bison is. Yeah. GNU Bison is so old, and it's very telling. But yeah, you can see we check if it's a number, parse Lex the next number, which just returns. The numbers are complicated because you might want to do some prefix leading zeros. You might want to do no leading zeros or just a decimal number, but you might also want to do binary or octal or hex, or I'm thinking of adding like base 64. That might be fun. And also I just, but it also always starts with a 0 if it's a one of these guys. Anywho, that is lexing and parsing. So you can see when we call next token or consume, like in parse block here, you can see that we literally just push to the children vector, right, of that we're creating. And then we parse the expression. So we parse all the expressions and store them in a vector. And then we make a node that has those children at this position that we saved, and then into the AST, right? Part of the parser state. So this is our output. And then this is just the block that gets returned from parse block, which then I'm sure gets added to its own thing. Where we set the left-hand side. I think left-hand side is just coincidental name. Nope, this is, yeah. We parse the left-hand side of everything. Basically, imagine if you parse a 1, it's the same as parsing the left-hand side of 1 plus 1, right? And if you parse a 1, you want to be ready to parse the right-hand side, which is why we do it this way. And you can also do unary operations pretty easily. For example, at. Anywho, we just call next token a bunch of times, and depending on what the token type is, we just make different types of nodes. That's pretty much all it is. And that's nearly all of the front end. That's all of the language part, right? There's also the type checker, which just takes in the AST and does a bunch of stuff based on the node type this time. Right, so we traverse the tree, I think bottom up. I think we do a depth first, bottom up traversal. Yeah, type check each child of the root. So for every child, we recurse, I'm sure. It's somewhere in here. Yeah, here it is. Jeez, I don't know why I couldn't see that. We recurse for every node, and then there's never another root, so it'll be something else. Like a function, in which case we type check its children, and then we go all the way down the left side of the tree. Saraid says post-order traversal is the term you're looking for. Yeah, thank you. Always forget pre-order, in-order, and post-order. It seems like it should be obvious, but it's not. I always forget. Anyway, type checking is part of the AST stage, and also part of the front end of the compiler. Yeah? Then we get to the tricky part, and this is the IR. Obviously, let's go through, first let's go through like source code tokens AST. So let's look at this little program. We have foo type inferred to 69 foo. So we have foo, which is an integer 69. Right? Oop, that was the wrong Emacs. I was already in the right one. So what we're going to do, let's head on over here. And beautiful. We're going to pull up a command that just rebuilds intercept. And then I'm going to run intercept. And let's just make a little... Do I have a test file already? I don't have test.int. Let's make test.int, right? And we're just going to write that exact program. That's what it was, right? Yep, that's foo69 foo. Ooh, we got a Discord message. I didn't mute it. Ooh, we got a new member. What's up, Mxp? I don't know how to pronounce that. What's up, Mxp? Thanks for joining the Discord. If you haven't already, be sure to join. It's a community of lovely people, and we're all very helpful as can be, and accepting of all. Anyway, foo69 foo. Source code of a very simple intercept program. I'm sure if you know the syntax of intercept, it's clear that foo is a variable that we're declaring with no type. It's an inferred type, which is the same as doing this, right? And eventually, once we get type of, it'll be the same as doing that. And I don't think we even need parentheses here. So it will be the same as doing that. But for now, it's the same as that. So we define foo, it's assigned to 69, and then we just return foo, because in intercept, accessing a variable returns its value, and the last expression in a program will be the return value of the program. So this program should return 69. Let's try and compile this and see what the hell happens. Test.int. Yeah, let's go assembly and code.s. Things have changed a little bit with the compiler, so if you haven't used it in a little while and you're on the instruction selection branch, be sure to type --help and get some help, because things have changed. Okay, beautiful, beautiful, beautiful. You can see we have a static reference to foo, which does nothing. This is a no-op. Just because we don't have a discard keyword in instruction selection, which is something we're going to do today. First time chat from Mooksp. Hey, it's Mooksp. You joined the Discord. Oh, Daniel joined the Discord too. Thanks, Mooksp. Welcome, welcome. It is so good to have you both. Nashiora, ayo, what's up, local? Welcome back. Lia. Sorry. It was like an intrusive thought. I had to do it. King Bun says, at Daniel, where are you? It's me. I am local. You remembered this time. Let's go. I did. I did, Nashiora. I don't know how I remembered it either. Okay. Thanks for waving. You're a legend. Okay. Let's start simple. We were doing the example program of foo69 foo. So first let's look at what the token sequence will be. Yeah? Taxborn? Have you been here before? I feel like I remember you. Yo, I started writing my own compiler in C this weekend because of your videos. I've been learning a lot through this, and thanks for being an inspiration. Aw, thank you. I can't wait to see the amazing program that you are going to create. Programs in your lifetime. Be sure to share it. I'd love to hear it. I should remove the Lia pronunciation and just do like local / Nashiora. That's not a bad idea. But that's... But you should choose... Which one are you going to choose as like your actual Discord username? Because they're making people choose now. It's kind of rough. Taxborn, I've dropped in once or twice before. Damn, you do have an insane memory for names. I don't remember anything. It's completely luck. And it didn't even give me like returning chatter because I haven't streamed in so long. I'm going all on, it's all me, baby. It's good to have you in again, though. This is the token sequence that would be produced. We can see we would have an identifier foo, and then a : operator, an integer 69, a semicolon, which is just a semicolon, and then the identifier foo again. If anybody gets confused here, let me know. I think everybody understands. You can split this into pieces and go, okay, we have foo, we have a : we have 69, we have a semicolon, and then we have foo. 5 things. Prab hate exit. Yes, exactly, Prab hate exit. White space is ignored in this language. It's almost never relevant except for in identifiers. And even for identifiers, there's semicolons and delimiters and expression separators within a statement. But we don't have statements, so it's kind of confusing. Isn't it 69? Nashiora, note, do not take it, I will find you. Oh, I hope you get local. King Bud says, that guy in Soding Discord named Malik size of your mom equals null gets me every time. It's too large. No mem. Ignore white space, Lexer Lex. I mean, you're not wrong. Let's go take a look at the Lexer. See? While is space, skip. It's true. We do this all over the place. We hate it. White space is no good. And comments are also white space. Ploink. While comment, skip. Okay, where are we at? We have some tokens. This is the sequence of tokens that would be produced by Lexing the source code. Right? Fairly simple. Nobody got confused. Nobody asked any questions, so we're moving on. This is where it gets slightly confusing, tree of nodes. But to do this, we just look at the first token and go, oh, it's an identifier. Let's take a look at our grammar. Which ones of these can start with an identifier? We have decal start. We have type base. But can type base show up at the beginning of an expression? No, as far as I'm concerned. So we don't have type base because it can't show up at the beginning of an expression. What else do we have? We have an expression, I guess it's not in here, but an expression access, right? Which is just an identifier, which accesses a variable, but you don't need to add that in the grammar because it's not anything, it's just an identifier. So all we have to check for is it a variable access followed, or is it an identifier followed by a colon? If so, it's a decal start. Otherwise, it's a variable access, right? Or it could be a lot of things, a function call as well, right? Because an expression call can be an expression followed by a, expression primary. That's the one I'm forgetting. Because we can just have this is where it is. I'm blind. This is where the variable access is. Pretty sure Twitch only supports ASCII. Yeah, it's sad. Straight says, otherwise I'd be eternal on here too. Ooh, it came through onto the Emacs even. Beautiful. It looks like it might be extended ASCII. I don't have, your name is confusing. Prab hate exit. Thank you so much for the follow. Saraid says UTF-8 go burr. I like UTF-8. It's a beautiful, beautiful encoding. And you can keep extending it. You can just like, oh, now I want 20 byte identifiers or 20 byte what are they called? I'm code points. There we are. You can have 20 byte code points in UTF-8. I mean, they're not part of the standard yet, but if we ever need them, we can just add them. Prob hot exit 0. Okay. That does help a lot. Is it prob hot? Prob hot. I'll do my best. I gotta really commit that one to memory. Yes, exactly. Oh, nice. Is it a Yush or is it not? That's right, that's right. Is it Ayush? Is it Ayush or Ayush? You aren't pronouncing the plus signs. Maybe you should spell it in IPA. You aren't pronouncing the plus signs. Of course. How ridiculous of me. Na plus she plus oral. Wait, what? It's pronounced Ayush. Nice, nice. Thank you. That's good to know. I may have asked you that before. I'm sorry if I have. Sorry, I saw you were streaming and rolled a Kong finger. I like how you put that. Yeah, I definitely partook. Anyway, I totally forgot what I was talking about. We're in the compilation overview. We're parsing tokens. In the grammar, we can see that there's an identifier. There's an identifier. So we have either a decal start or an expression primary. And really, that means that after we parse an identifier, we have to look for a colon. And if we get a colon, then it's a decal start. Otherwise, it's a primary expression, in which case we have returned an expression, in which case we can go back to the top level of the file and find another expression. Or continue parsing because there's another... It's a recursive grammar. So a call takes an expression and then maybe followed by a left paren or a subscript, maybe followed by a left bracket for an array access or pointer arithmetic, really. And then we have cast, right? Which also takes an expression and a keyword as. It's complicated, right? So really, we just have to check for all of these things, and you build it from the bottom up. That's at least how I do it. I go, okay, I want to return a value when I have an identifier or a number. And then I want to be able to assign something. And then you build the assign syntax, and then, you go up from there. Anywho, at this point, we have type inference. So we can say, okay, foo is 69, we have foo. In order to parse that, we loop over these tokens. Where were they? There they are. Identifier, colon, colon, integer, semicolon, identifier. Sorry, it isn't that hard. The space in there really makes it different. When people say my name funny or exaggerated, that's all I can think, that I'm low in calories. Low cal. I'd write down how to pronounce Surrey in IPA, but it's too hard to pronounce, so I won't bother. It's an old Irish word. Yeah, if you want to pronounce it correctly, it's a... I don't know if anyone can anymore. Did you write the grammar before you wrote the nodes, or did you build it alongside Lens? I definitely wrote the code first. I am not one to plan things out. So I just wrote the code with I started with the enums, I'm sure. And I was like, okay, what type of nodes do I want? And this is as much planning as I did. I'm sure I got, I want a root. I want a variable, right? And maybe, I need a reference or a declaration. And then I'm sure I went, that's good. I'll start there. And then obviously I also had I don't know, a literal node. That's what it is for numbers and stuff. I probably would have added a literal node, a variable reference, and a declaration, and then that was it. I just started. I didn't think ahead. This is all retro documentation, right? I wrote this week. This is how you says you built it the best way. Thank you. Thank you. Thank you. The best assumption that I can make for the first consonant is g. One of those glottal G's. Or near glottal. It's not quite glottal. That's a voiceless, palatal, non-sibilant fricative. Voiceless, palatal, non-sibilant. Like that? So a fancy sh. It's not really an SH, I don't think. Sorry, wrong. That's nonsense. I was trying. I was like, what did you just say? Alveolopalatal. I've never seen it written like that. So it would be kind of like between an S and an SH, almost literally. It's voiceless, so it's really going to sound airy because it's a fricative. And then alveolopalatal. It's right behind your teeth. Not sure why I called it non-sibilant, because it's clearly sibilant, lol. That's what I was gonna say. I was a little worried. Is it Ayush says, man, I'll stick to ASCII. I like the IPA. It's fun. It's fun. I should do a linguistics stream. Anywho. We build the tree of nodes. I'm sure we get there. This is the tree we produce, and in fact we can double check this by looking at the AST output, because I typed print AST and we actually get the AST now. So you can see we have a root node with a declaration and a var as a child, and then the declaration with foo, right, is an integer type, and it has a literal as a child with a value of 69. If we take a look here, we have a root, a declaration of foo with a type integer, with a child, literal 69, and then a variable reference as a child of the root. It goes well. And this is the node tree produced by parsing tokens, produced by Lexing the source code. prop how to exit 1 says nice pretty print. Thank you. Oh, nice.
Sha. Sha.
Yes. This is the tricky part. So it's like because your tongue's on the bottom. Not on the bottom, but like the tip of your tongue can't be touching your teeth. Otherwise it'd be dental. So it's, yeah, it's a complicated one. It's going to be like that's complicated. Like the word hitoi is partway sounding like yeah, shihoi. You gotta have the good accent. Oh, by the way, this PDF is available on the GitHub, and GitHub has nice rendering of PDF, so you can follow along if you want. Nashior says may do be. Between S and Sha. We were on the tree step, Lens. Okay. This is where the notable actions takes precedence or comes into effect. Hey, which effect is that? That'd have to be the one with the E. I'm getting distracted again. I screwed up the chat. I fixed it. So with the tree, we have a notable action taken at this step on this data structure. So we have a token sequence converted into a tree of nodes, and then this tree of nodes has a very notable action take on it called semantic analysis. Semantic analysis is the act of ensuring a given program is semantically valid. Basically, that's fancy terms for saying that you can't do things that aren't allowed in the language. Like if you don't allow variables to start with underscore, if you don't allow anything that's an error, right? So like if I did this, something that's not a type, let's try and compile this now. Okay, we have a redefinition of symbol foo. That's funny. I didn't get the error I expected. There we go. Here we have type integer literal is not convertible to not a type. We don't know what not a type is, but we know that we can't convert an integer into it. So this is not a valid statement in the program. And if we were able to go further past this expression, we would realize not a type is not defined anywhere in the whole thing. But there's a variable declaration of it. So obviously you can't declare a variable to an incomplete type. So where does this error come from? When does this happen? And this happens in semantic analysis. That's why I'm mentioning this. This is the semantics of the language. If you have a type, you need to know what it is to be able to instantiate a variable for it, right? This is a linguistic stream now. It might as well be. I'd have just as much fun. I will educate people on Japanese in this stream now. Yes, everyone jump in the Discord. We're learning Japanese. I like sushi. Hey, I do too. Prob HUD exit. It is in the about section if you're on mobile. Mr. Mugame, bro, I'm crying. I am still working on the Java game project for school. And why the fuck does Java implement their drawing things inside the JVM? Oh, you just discovered that? And why is the standard so bad that the behavior differs from JVM to JVM? Prop exit. Got it. Nice. Aren't you using java.awt or something outdated as hell? Yes, he is. Daniel, hey. Damn, Daniel, what's up? How's it going? Daniel Spoketh. Is that, I'm killing myself. Is that the right conjugation? I don't think Spoketh is correct because I used a third person pronoun or just noun, proper noun. If I was talking to him, that would have been correct. Well, no, it wouldn't, because I'm not talking about... Yeah, I used the wrong conjugation. Is it Ayush says, no, we were on notable actions. Thank you. So, semantic rules. We basically just want to say whatever the program should do, it should do, and whatever it shouldn't do, it shouldn't do. I know that's vague, but that's literally all we can kind of say, because it's everything from, if we take a look at the actual code, you can see we have everything from ensuring that we can resolve function overloads properly to ensuring that we have convertible types, and we have a convertible type error here. So all of that is done, a bunch of type checking, and then function overloads are resolved, and then what else did we do in here? Lots of function overloading. We type check types. So if you have a user defined type, we need to make sure that it's a valid type. Any primitive is of course valid, but if it's a named type, then we want to make sure that the type that this name is aliased to is also a valid type, either a primitive or some other user-defined type, maybe a struct. And for a struct, we want to make sure each member has a valid type that's defined and well-known. That way we can get its size and alignment and things like this to build the struct. And if we can build the struct, then what do you know? We can type check that type as true. And then with integers, they have to fit within... this is for arbitrary integers. So obviously like integer and byte are primitives, but for things like I32 or S32 or U32 or whatever you want to write, bit width specific arbitrary integers, we can't have a 0 width arbitrary integer. That's a little ridiculous. And if it's greater than 64, we currently reject it because it's going to cause a whole bunch of mess, and we wouldn't support it in the back end anyway, so there's no use case for this currently, but we will add it. Mr. Mugami says, I'm just going to start implementing in Java native functions. Is it Ayush says, it's like a Lisp. Oh, not Lisp. LSP. Is that how LSPs work, Lens? Yeah. I think what you're asking, I wouldn't say that's how LSPs work. LSPs follow like a protocol that's really specific, but they do have to end up parsing the stuff into an AST and finding errors. But most of the time, it just kind of piggybacks on the compiler itself and then spits and then like reads this format of error and can spit this back out to you, because it can just take this, right? This line. All that's needed is this error line, and then it can take this message after parsing. This is the file it's in, this is the line, this is the character, offset. So this is where you move the cursor to in an IDE, and then you parse error, and then you go, okay, and then show the user this message, right? So most of the time they just kind of piggyback on the actual compiler and parse errors. Or you have it built into the IDE, or you have an IDE support an already existing grammar where errors are well defined. Nashior says, I need to learn to tech like this. It's really easy. I'm not good at tech. Do you want to look at this horrible stuff? It's terrifying. Is it Ayush says, imagine if your compiler detects an LSP and reading it and says, hey, that's cheating, do the hard work. That would be funny. Show me the tech. How do I tech? It's pretty easy. You need a document class. So it says, Zlatech, nice, yes. So you make a document class, start with article, because you don't need to know more than that right now. Write begin document, followed by end document. Say this is a test. With this, And with this, compile that using XELaTeX, like so. Just feed it the tex file. It'll look crazy and do a bunch of nonsense. And then you will end up with somewhere output written on compilation overview, blah, blah, blah. And then just go to this file in a PDF viewer. I prefer Emacs. And then it's here. Does that make sense? Hopefully that makes sense. I'm pretty sure it just ignored the, I probably didn't save it. Luckily. Anyway, as you can see, that's all you need to do to start out. And then you can start to like, oh, I want to put something in the center of the page. So I'll put it in a center, in a centering thing. And then this is just the title, because I want large, bold font with Intercept Compilation Overview. I want an empty line, empty small line, and then a smaller subtitle, and then I want just a bold author name. It's complicated, but it's not that bad, because it's just begin document, end document, text in between. I like to write stuff. This is a new paragraph. And then from there, you can go, hey, I really hate it, like how the first paragraph isn't indented. It's really annoying because by default, this paragraph wouldn't be indented, but this one would be. And that hurts my head to try and read. So what I did is I looked that up and I found this. You can just use package indent first, and then it works. Boom. Easy. Easy. It works. Finally. I don't care. To be honest, Word is harder, at least for people who've used a markup language once in their life. Absolutely. Because this is really just complicated Markdown, if you really want to get into it. But then you can do amazing, way more complicated things because it's actually Turing complete, and you can typeset very variably, and you can make pictures, for example, this big graph. And then TXZ has its own libraries, like fit and positioning. So fit lets us make a node, for example, down here, which is just a dashed line, the circles around talk, AST, and IR, and those are just 3 nodes that I've created in the TXZ picture, talk, AST, and IR. There's no preceding paragraph if it's the first one. Well, I don't like how it looks. In this document. I do everything on a document by document basis. I've never looked for this package before or cared, but on this document, it was getting out of hand and it was killing me. So this, it makes way more sense to me to not have that indented because it kills me to, I didn't like it. I didn't like it. Anyways, hyperref is kind of a standard as well package for just having non-terrible references. For example, autoref, where you can just reference something and it'll name it for you. So sequence of tokens that would be produced by Lexing, the int source figure, which I've labeled. Hopefully that makes any amount of sense. I'm using figures in float barriers, but it's not a good solution. For the same reason we typically don't indent paragraphs after figures, display, math, tables, etc., etc. Yeah. It's your document, so do what you want, but what I will say, as a typesetter, this physically pains me. We'll see how much of a difference it makes. Maybe the document looks different now. What just happened? Maybe the document looks different now, and it'll be fine. Maybe I won't notice. Plonk. See, after this figure, it's indented. I wonder if we can fix that. Maybe this is what's killing me, is that this isn't indented and this is. And then I really don't like this, now that these are indented. Why are these indented? because it thinks Fido copy is a paragraph. Okay, I'm gonna keep it. You have to fix those manually, unfortunately. Yeah, of course. I'm gonna keep it just consistent. Gonna keep it consistent. The right solution is to add no indent everywhere. That's not the right solution. Pan spinning kids, thank you so much for following. I don't know what that means, but it's funny. Okay. So, semantic analysis does things. Intercept requires a program return value as the last expression present in a program. And it requires compatible types when you're assigning and etc. I should say convertible, not compatible. Anywho, we type check a bunch of stuff. And then it gets to the hard part. Code gen. Indenting the first paragraph is like leaking more memory on purpose because we're leaking everywhere else too instead of fixing the memory leaks. Yeah, that's fine. No indent followed by a tab. Oh, if only tabs did anything in LaTeX. Is it Ayush says, wait, that wasn't the hard part? What we just described took me like a month. Everything from this point on has taken me 8. If that helps. There's a reason there's a difference between front end and back end. Back end makes you want to gouge your eyes out. Front end is easy. It's all like, oh, tokens, nodes, make new data structures. It's easy. No restrictions, no requirements. Just represent the data however you want. And then you have to come back to reality and realize, oh yeah, we need to like figure out what registers to assign to what things and at what times. And oh yeah, how are we going to do that? And oh yeah, how about optimizations? How do we apply optimizations? Oh God. And then, oh God. It's bad, right? And this is where the IR comes in. Intermediate representation. And basically, code gen starts out by creating a main function, right? It just creates the main function. Nothing too complicated. And then all of the functions that have been defined as nodes, we emit those as functions as well. So we collect all of the functions in the program. And then we optimize the IR. Now, the interesting part here is codegen function. Right? Is it not codegen function? It's codegen expression, that's where it is. So for example, emit the main function. The root node is the main function, so we just emit the root into the main function. And this expression can be apparently a whole bunch of stuff, and it's recursive. Legendary. Pan is the nickname. Spinning Kids is the demo group I used to hang with. I see. What's up, Pan? It's good to see you. Thanks for chatting. Sorate says, it's fine. I'll just open a PR and add no indent everywhere if you can open a PR on a PR. I think you can. I don't normally have OCD, but if typesetting is involved, I get pretty annoyed if it's not typeset properly. That's fair. I can go through and do it too. I just don't know if I'll have time like today. So it says, like typesetting headings in all caps and italics. Seriously, why? I don't know why anyone would do that. That sounds terrifying. You're talking about like news, like a newspaper? I think I've seen that on newspapers. Normally it's just the like Cooper Black. So it says no. I didn't do it, did I? One sec, I'll send you a screenshot. Oh God, okay. Someone said, Nashiora, / no indent, color them nodes. / no indent, the middle bit is the hardest part of the front end, and it's still a cakewalk. Yeah. The IR. So basically for the IR, we omit the root. For the root, we just omit all of its child expressions. All of its child expressions may be anything. If it's a function, then we want to make a function reference because lambdas and stuff like that. And first class functions. Anywho, there's L value stuff. I don't think you need to worry about any of that. But when you reference a variable, you load the address of the variable. That's not, I think, too complicated. And you'll notice this is where the IR underscore functions begin to be used, which are defined in CodeGen intermediate representation.h, declared, and defined in .c. So let's look at IR load. It's not here. Hold on. What was I just looking at? IR load. I swear that exists. Can you take me to the... Yeah? Okay, can you take me to the implementation? It cannot. Okay. That's interesting. Am I crazy? Okay, that's here. Ah! I'm getting it. All right, check off topic. I'm on it. Oh, Taxborn and Prabhat Exit 0. What's up? What's up? Thank you for joining the Discord. It's so good to have you. LaTeX defaults be like /chapter foobar, chapter 1 foobar. Yeah, this... You just described a hatred I have of chapters in LaTeX. I almost never use chapters. I hate them so much. I use sections. Sections are awesome. The chapter 1 thing is already bad enough. This is using the book class. And then it all caps it. That's ridiculous. So at the beginning of the page, chapter 1 dot foobar in all caps in italics. Naturally. Yeah, naturally. That's what someone would expect to happen. Not to mention, why is... Okay. I'm not going to get into it, but it is crazy. Serrade with skull. I know what you mean. I haven't added that to the to the thing yet. Oh, I don't know why that's so funny to me, but that's so good. Capitalics. Ooh, I like that, Bunzy. I like that. Capitalics. Wait. No. We can't have italics in here. I'm the streamer. Yeah, the chapter formatting where it puts the name on a separate line is also horrible. So I tend to fix both manually whenever I need to typeset a book. Yeah, when I'm typesetting a story or book or something like that, I basically just redefine chapter. It starts out with like, oh, I want to tweak this. Oh, I'm going to change. And then it's different. I end up just using something else. How often do you casually typeset a book? Too often. So it says, which basically involves redefining chapter. Yeah, exactly. Exactly. I can show you an example of how I formatted chapters for Egma's Erogen book. Nice. That's right. That's a good book. It's terse. I will say that. So, IR. We code-gen the AST into the IR by walking the AST post-order traversal. And effectively, depth first, post-order. I don't know if I need to say that. Wow. First time chat from Expert G. Isn't there a compiler already written? Come on, don't reinvent the wheel, man. Well, that's just like your opinion, man. There's plenty of compilers. This is the one I made. But yeah, we basically traverse the tree and code gen it into IR sorts of things. The IR is a control flow graph, and it's also a re-representation of the program, an intermediate one, if you might. It's an intermediate representation of the program where the variables, the temporaries in the program, are actually all separated. Oh yeah, I screwed up. Test.int, that's where it is. The temporaries of the, what did I, yeah. I'm trying to run XE-latex now. Control C to exit, but it doesn't exit. I'm pressing Control C. I'm stuck. Help. Okay, there we go. Had to get there. Remove x.log. I put another screenshot in off topic. Legendary. Didn't I run this file? Maybe I'm crazy. Okay, this is the IR. This is the AST. It gets generated into this IR, where the function entry, we have two parameters, and those go in some temporary value. So the things in blue here are temporaries, and they're just numbered for convenience because they don't have names, right? What would we name these temporaries? We just have to generate one, and a number is the easiest way. Ayush says, what happens with the AST after semantic analysis? That's exactly what we're going through now. It gets code genned into the IR. So, for example, for a member access or a variable reference, then we code gen don't worry about this part, but we load the expression's address, right? So we load from the address of the variable or the member into this IR instruction. So this creates a new temporary. IR load creates a new temporary within expression IR. And the AST actually references back to the IR, as you'll see. And the IR is stored in the CodeGen context. We'll get to the overall structure of the IR as well. So the AST is converted directly into IR. Sorry, it says, yay! Well, yeah, CodeGen first, but then yay! But what are we genning, guys? IR, intermediate representation. Let's go over the form of that. Let's take a look at the real-world example. Well, make it a little bigger. As you can see, we've codegen the L value, which is just this reference to foo, a static variable. And then we load this reference to foo, right? This reference to foo loads into the temporary 3, a pointer to integer. Load 3, right? The temporary 3 in IR. This means that we are taking this pointer to integer and loading from it. And based on its type, we're going to say, oh, a pointer to integer, if you dereference that, you'll get an integer. So that's the type of this IR instruction, of this particular value that this IR instruction produces, that is. So 4 is an integer, 3 is a pointer to integer, etc. And then 3 is used by a load and things like that. Hopefully that makes any amount of sense. So we get to the declaration. We go, okay, it's a declaration, codegen the L value. And then after that, we have a variable reference, in which case we codegen the L value again, but we don't omit multiple references to the same static. So we just use the same value that we have before, and then we load the expression address, and that is where this load comes from. We're loading the L value, which is foo, right? We're loading foo. It's kind of complicated, but it's not too bad. It's very similar to assembly, but even higher level than that. So easy. I wouldn't say it's easier, but it's higher level. Because obviously we have things like function definitions, and you can call different functions. We won't get into that because it's complicated, but you can have functions, parameters, basic blocks. So the overall structure of the IR is basically functions. It's a list of functions. That's how we represent the program. The AST is just a root tree. It's a tree, right? We have the root node and everything stems from that. That's the program. The IR is different. It's a list of functions. So we have a vector of functions. In this case, there's only one. It's main. And in this function, we will have a list of blocks. Basic blocks is generally what they're referred to as, because a basic block is basic in that control flow does not enter or exit anywhere except for at the very beginning and the very end of the basic block. For example, we enter the function main, and then we enter basic block 1. Within basic block 1, each of these instructions have to go sequentially in order before we reach ret, the last instruction, return, right? In which case we will leave this function. So the last instruction of IR will always leave, it'll always be a branch, a return. It'll always yeet you out of the basic block. You'll never have a basic block fall through into another one. That's not how basic blocks work. The definition of a basic block is that there's an entry and an exit, and all the instructions in between have no branches, no control flow changes. So something like a while loop or a for loop require multiple basic blocks. Same thing with an if statement. That way you can get to the end of a basic block and then choose to go one way or another way, aka jump to another block or a different block, the if or the else or the join, right? Okay, where are we at now? It's defunds assembly, yeah. So our goal is to convert the AST to assembly, and the IR is just a step in between. Yes, that's perfect. And we can even take a concrete look at that on the first page. You can see the IR wants to turn into target code, which is our assembly, x86-64 assembly. And to get there from the AST, we do convert it into IR. And then more stuff. Don't worry about that. We're getting there. But yeah, the IR is where it gets compilery. I do know that, right? It's very complicated. The AST is the full program, but it's way too high level for like a machine to comprehend. It would just basically be an interpreter if a machine computed in this way, where it had different nodes that it goes depth post-order traversal on, and then it doesn't make any sense. Okay. Isidiush says, it'll take some time before I digest this. That's okay. That's perfect. It's taken me very much large amounts of time, and this is not the first document that I've created in this vein. There's also this one, right? Which went through an older version with different register allocation, and it's crazy, right? I've done this too much. So don't worry, it is definitely one of the hardest topics I've ever gotten into in programming, is IR and compiler backends. But it's so much fun. I'm so behind on the chat. I'm going to catch up right now. King Buns. Yeah, because IR can then be translated to multiple assembly instruction sets. And even multiple instruction sets doesn't even have to be assembly. You can target different instruction sets, I think is the proper term. Perfect. Yes, yes, yes. Isidiush says, how do we ensure our code will work on most machines? I'm not sure what you're asking there. Could you clarify? Because we can't. We don't make the machines. We don't even know that the machines work. But we can ensure through semantic analysis that the program represented by the AST, if properly cogenned, is a valid program and won't fail in any catastrophic way that's unintended for the language to fail in. Because it might just assert 0 and fail. That's fine. That's not a failure. That's proper computation and exiting the process. Mr. Mugame says, my conversion from JS has begun in starting to write semicolon at the end of comments. King Buns, Isidiush, that's LLVM's job, I think. I mean, no, we don't hand anything off to LLVM. We're full stack. Isidiush says, so all we got to do is make it assembly and give it to LLVM. I mean, that's what I started with. That's the easiest. But we now produce object files with machine code in them. King Bun says, no, you give LLVM the IR and specify what assembly you want to target. That's if you're using LLVM as a backend, yes, which we're not. Kingbun says, unless you build your own backends for every different machine you want to target. Yep. That's the whole point. Yeah. That's the n times n problem. Izzet Ayush says, there must be a limited number of instruction set, right? I mean, if you think yeah. That's why we have solved the n times m problem in this way, so that we only need m implementations, aka the amount of instruction sets that there are. That's how many implementations we need to support that many instruction sets. Whereas before, every language would require a target for every instruction set it wants to support, and not even every instruction set, every target. So that might be calling convention is different. That might be OS is different. That might be syscall calling convention is different. It might be a different version of the OS. It might be a million things, right? So you really want to cut down on the code duplication, and that's what this IR does. There's a wonderful picture that I'm going to Google for, because I don't remember where it's from. N times m problem. But let me see if I can find it. Yeah. This is good enough. So as you can see, we basically have any amount of languages can be converted into the IR. The IR is high level, right? It's not specific to one architecture. It's just loading an integer. That's not really that complicated, right? We just load integer. That's it. Return. After you call a function, presumably you need to return. And every computer that wants to support this IR will probably have some way to do that. For example, RISC has like BXL or whatever it is, branch with exchange and link, right? x86-64 has RET. Oh, we got Discord stuff. Oh, beautiful, beautiful. Welcome, everybody. So good to have you. Anyway, this is so high level that any instruction set should be able to implement it. That's kind of the point of the IR, is that it's an in-between. And then also there's another thing is that with these temporaries, we have gained a lot of knowledge because we now know that this temporary is defined by this instruction. 3 is defined here. 3 gets assigned to here. Its last use is right here, which means that if we have a register that we want to assign to 3, then we know, okay, this is where it's defined and this is how long it needs to be live for, right? How long it needs to be non-clobbered. Which is never. It can be clobbered right away because it lives for one instruction and then this is its last use. So 4 and 3, then you know they don't interfere. You could assign the same register, then you have load racks. Everything goes in racks and you have fun times. By the way, I put another screenshot in off topic earlier. Totally missed it. Ooh, see, this is beautiful. This is really good. You did great, Saraid. Everybody would look at this and go, oh, there's another giant section of the book coming, and it's about Chadmanib. My origin is rusty. Phonology of Arajunkat. Arajunkat? I can't remember what the A is. Azadiush says that looks nice. Yeah, I agree. We got that chef's kiss. Perfect. So the IR is so high level that we don't really specify anything. And in fact, we specify so little that the parameters could be anywhere. This could be a stack-based parameter. It could be a register. It could be anything. We just know that we load it into the temporary one right at the beginning of the function. And then later on in the function, if we ever reference the parameter, it's the temporary one. Anywho, there's some notable actions. There's quite a few. Let's take a look. Where's Emacs? Jeez. Okay. there's some notable actions. Let's take a look. By the way, this is just the IR we're looking at, but I feel like the syntax highlighting helps. And we don't need this. Notable actions, optimization, target-specific IR lowering. So if we take a look literally at codegen.c, you can see that after we actually codegen everything, all the functions, the main function, etc., we just say, oh, if we're optimizing, optimize. We don't need to go in how optimizations work. That's a whole thing. But basically, the IR works in a certain way where you load a thing, and we know what the IR load instruction does, and we know the value that it should produce. Right? And we also know things like binary instruction cases. Yeah. So we can do const folding and strength reduction, where, for example, adding 0 to something is a no-op. We can just return that something. So if we add an immediate 0, right, as the left-hand side of an add, to anything, then we just replace the uses of this add instruction with the right-hand side, because we added 0 to it, it's the same value, and then we just remove this whole instruction. And also, yeah, we just remove this whole add, and it's never used again. And then same vice versa, because it's commutative, yeah. So you can add syntax highlighting support to the thing then. Shouldn't take too long. I thought about adding an assembly and an intercept IR assembly syntax highlighting to the latex highlight code package. I might make a PR still. Pos420 says, hey, what's up, low-level gang? What's up, Pos? So IR has a format, and we turn our AST into IR. Does IR get taken care of by the system? No. But yeah, so optimizations, basically you go through and replace instructions or reorder blocks or blah, 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 blah. Don't worry about it. Tail calls, stuff like that. Optimizations. We'll get into that another day, or you can go back to the streams where I did those and went over all the optimizations we have. If I've done one. I don't remember, to be honest. Anyways, then we do this thing called lowering. And if we take a look, lowering changes the IR. We have before lowering, and then we have after lowering. And what you'll notice mainly is that things like calling convention for functions have been filled in. So we know now where this parameter is. It's actually a register, and it's the R2 hardware register. So we know where this parameter is going to go because the calling convention dictates that for us. So this is already an invariant of the program. So we specify that after lowering in the IR. This is different from before. Don't worry about it. Pos420, how can I get into the low-level system stuff? I found that really cool, but also daunting. Pick a project and do it. Seriously, that's it. Just pick something you're interested in and don't stop until you've failed many times. I'm serious. I know it hurts to hear, but Izzet Ayush says, tune in here. That's sweet to say. You may learn a thing or two by just watching, but this is not a tutorial channel or anything. Pos420 says, let's go then. Lamau. Okay, so optimization, we went over that, and then target-specific IR lowering. We can't just lower the IR the same for every architecture. So we say, whatever architecture we're actually targeting, lower it for that architecture. And then within this, we may even further specify, because x86-64 may have different semantics based on whether or not you're lowering to the calling convention for Microsoft or Linux or stuff like that. And again, I think I renamed that already, so I should say Microsoft or sys5. So this is lowering, and then after lowering, we basically, anything that can't be represented by the x86-64 machine should be converted to something that can be represented by the x86-64 machine during lowering. So what I mean by that is like param, there's no way on x86-64 to like get first function parameter, right? That's not a thing. That's not an assembly instruction. It's not anywhere in the hardware. The hardware knows nothing about anything to do with calling conventions. So we want to replace all these parameter references with the actual registers they'll end up in. That way we can truly propagate everything and actually represent this parameter on the x86-64 machine in the form of a register with a type. Hopefully that makes sense. So R2 and R3, these just apply to I'm pretty sure on Windows, so RCX and RDX, which are the first two non-aggregate parameter registers on Microsoft Windows. Isidish says no hardware care. Nashiora, I have mostly returned from work call. I can join the conversation again. Legendary. So good to have you back, local. We're at the point of IR. We've just gone through optimization very quickly and lowering more in depth, where we convert parameters to registers or stack loads, right? So if you have a ton of parameters, then we will insert a stack allocation and then a copy from a pointer loaded from the base pointer. And you know what I mean? We do all that in the lowering stage. And that's when I don't know why we're printing it twice. It's probably just a bug with me adding in a print somewhere because it's development and then accidentally committing it and keeping it. It doesn't matter. We'll figure it out. And then the calling convention also states that the return value goes in RAX, which is called R1 in this scenario because it's the first register we defined. RAX. Nashior, probably just a bug. Scary words. It's fine. There's plenty of bugs in the code. It still works. We reduce them as we go, and then we add a ton, and then we reduce them, and it's kind of the cycle. Anyway, we go from AST to IR. We go from unlowered IR to lowered IR. And that is where we used to just emit assembly or machine code from. We used to just use these IR instructions and emit them. But these IR instructions aren't like machine instructions. So when we loaded like something larger than a register, we would have to actually code gen like multiple. And then that meant we had another lowering phase. And it was just a mess. It was a mess. The word just is what I'm scared of, Lamau. Assuming it's simple, it could nuke the planet lens. Be careful with your bugs. Lamau. Anyway, we don't do that anymore. Nuke the planet. No, we don't do that anymore. We don't generate code from the IR. We now have more stages, which is why I made this whole document. We now have the general machine IR. So the IR gets converted into yet another data structure called the general machine IR. That's what this thing is. Now, this general machine IR is much more like machine instructions versus actual IR for optimizing and useful SSA. So it's at this time that, for example, phi to copy happens. In the MIR, any phis that show up, if you don't know about phis, just ignore this. Any phis that show up, we go through and insert the copies necessary for those, right? Which also means that SSA has been destroyed, because by inserting those copies, there are now multiple definitions of each value. We don't have that in this particular MIR, but it's possible. So for example, well, in this IR, we do have V0 and V1 and R1, and they're all different. You could have V0 and V0 and V0. There's no reason that the register can't be defined and assigned to multiple times throughout a program. Whereas in the IR, there's an invariant static single assignment where every temporary must only have one instruction that produces it. And that's broken in the MIR. POS420 says LaTeX. Oh yeah, that's how I wrote this PDF. So anyway, you can see that it's in large part a simplification of the IR, the general machine IR, because anything that's not a machine instruction is thrown out. Anything that isn't actually concrete needed to emit code, thrown out. And all the operands are inlined as much as possible. For example, on most architectures, you don't need to insert like a... you can calculate pointers as operands within an assembly instruction. So just for a concrete example, we can move foo rip into racks. So we can take this memory foo, right? And we can use that as an operand to this move and put it into the racks register. So we don't need to like move foo, right? Don't worry about that. Move foo into racks and then move racks into RBX, right? And then move RBX into racks. And that would be a Leah. So we don't need to like load the address of something into a register and then dereference it that way. We can just directly dereference this. So there's no reason that that extra bit of, that extra instruction, that Leah, is necessary, which means that it's just removed. And anytime we reference a static reference, we actually just have it as an operand. You can see that there is a static reference defined. But this, I don't think we truly need this. I think I could remove this and it wouldn't be a problem because static reference is currently just a no-op in the targets. And they're not in the ISL either. We'll get there. Anyway, so we load the static reference, which is going to be a move into V1, right? Which we don't have a register for yet. And then we have return V1, which means we're going to move V1 into the return register, racks, which we already know, right? So V1, we're going to move into R1, and then we're just going to have the return instruction. And the reason there's these gray numbers, this is the size of the virtual register, because this is an integer type, which we know in the IR, but not in the MIR. Don't worry about that. So every one of these registers also has a size associated with it, because there's type information in the IR that we need to retain. Anywho, then this crazy thing called ISL happens, and this is where it gets, this is what has taken me some time. What we're going to do is look at the x86-64 instruction selection thing. Okay. This is an entire new language. Is it Ayush says, it'll take time before I get the backend. Don't worry, I still don't get it. This is an entirely new language that I've written, and it's a domain-specific language. It has a very specific purpose, and its purpose is to define patterns that will be matched of this MIR, and then the result of that pattern, aka the MIR that will be emitted. And this stage, instruction selection, is a doozy, right? It's a lot. But this stage converts our general MIR, our GMIR, into our lowered MIR, where we actually, well, it nearly does, into our lowered MIR, where we have no longer any generic instructions. There's no, like, for example, when we insert a copy of an immediate into the I1, like, right, this could be V1, anything. When we insert a copy, I was looking at this right here, don't worry about anything else. To insert a copy in x86-64, before we would just emit the assembly of, oh, emit a move like this. But to generalize that and actually store that data in memory in the compiler, that means that we need this, an mx64 move. So for x86-64, we have a move instruction. And what we want to do is move the immediate, right, that we were given, the operand, into I1, the result register, which is most likely a virtual register, but maybe anything. So for example, when we come upon this load of a static reference, let's take a look at what that will produce. Load of static. So when we find a match, a load instruction, an IR load instruction, into I1, which has a static reference operand, and we just called that source, then we want to emit a move from source into I1. And you'll see that what we've done in the assembly is emitted a move from source, this is the static reference, into R1. I don't know why we didn't choose racks for this, because we don't have coalescing yet. That's right, that's right. Nashiora, I still love the idea of embedding DSLs into things like compilers. How did you make this compiler? Well, first I had to make another compiler. You're not wrong. But this is not a compiled language, I don't think, in any traditional sense. It's basically just a data structure, right? This could just as effectively be like a C++ match pattern, which you define with an opcode, right? Like .opcode equals blah type of thing. But this is not good. This is not ideal, right? And then you would just say, like, auto match 1. And then just make a bunch of these, or just vector push, right? You could push it on the back of a vector, you could do a bunch of things. And then you could say, like, dot operands equals another array, which is match pattern operands. And then you could do all this sort of stuff. And that's kind of exactly what this is, but it wouldn't be, I don't think there's any idea. Now Shreya says, nah, yeah, but still a fun thought. It is. So for our load instruction, you can see that that's exactly what we emit, is a move from source to I1. Yes. And you can see when we dereference a register, so when we load from a register, we want to treat that register as an address. So we want to move from source into I1 with the offset 0. I think this might be in the wrong order, by the way. I think this offset 0 needs to go in the middle, but don't worry about it. Maybe incorrect. I'm just going to leave myself a little note. And there's probably a lot of incorrect patterns in here, because I haven't taken time on this. Anyway, this is a very limited and stripped down DSL. So basically, we can only match and we can only emit, and that's pretty much it. Variations of that. And then you can also make new instructions, which was difficult. This was a difficult one. But you can make new instructions, new virtual register temporaries, new anything. So you can do one-to-many encodings, many-to-one encodings. You can do all sorts of patterns that you want to do. After this, we are in a very good place. And in fact, this is after we call cogen lower, we call cogen emit. Emit then just calls the architecture specific emit, which means that we are now in here. Where a lot of stuff is done. We make a machine description, which has, this is what register allocation uses, and a few other things during this, so we make it first. Anyway, this is where if we're generating a generic object file, we'll init it and all of its sections. This is where we emit static variables. So for example, this is where we're emitting in code.s this stuff, the section.data with foo. That's all here. And because we need to emit the static variable somehow, right? So we do that here. We create symbols within the generic object file that says, oh, this is a static and goes in RO data. This is a BSS and blah, 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 right? We do all that stuff, uninitialized, initialized. Then we go through and we do name mangling, right? And then we also do some unused block type of thing, but this doesn't get used anymore. I think it may break things, in fact, so I should probably disable it, but we'll worry about that at another time. Optimizations may break things in a work-in-progress compiler. That's kind of expected. Anyway, we get rid of blocks that are never jumped to or used. That's kind of the idea of right there. This should just happen earlier, I think, in the actual optimization, but we'll get there. We'll get there. Here's the real kicker, MIR from IR. So this was that stage from here to here, right? So to produce this from this, it's kind of, you just walk the IR and then go, okay, what do we actually need to emit? Registers are operands. We don't need to emit instructions. Well, we do need to emit instructions, but we remove those because we can inline them as operands. And don't worry about any of that. We create this from the IR, right? Then we lower anything that we need to encode. For example, this might be, yeah, this is in the wrong spot. This shouldn't be here. Don't look at this. This is all wrong. We get the MIR from the IR, then we go straight into ISL. This is just from before. It's so much stuff in this file has moved around. Because RA used to happen before our version of instruction selection, so everything's kind of switched and swapped and things are still in the wrong place. Don't worry about it. Anyways, then we do instruction selection. So we parse the file into a bunch of patterns, and then with these patterns, we do selection on the IR that was generated, the MIR that was generated. And after ISL, yeah, we get some warnings. After ISL, if you want, we can print the patterns. It's not too pretty. But you can see that we have, oh, match a copy with an immediate equal to 0, and emit, move, an operand, 0, 0, which is this one, the immediate, into instruction 0, which is an instruction reference, which is copy. You can see that this is just the same, the literal data structures that were generated from the ISL file that we're looking at here. Yeah? Pretty simple. Don't worry about the segfault. I haven't rewritten the printing code to handle a certain case where you can reference an output instruction from another output instruction instead of just pattern instruction. Anywho, after instruction selection, we do RA. RA, sadly, has become simpler and simpler, but it's very complicated. It has to do a lot with mathematics. We build a graph and then use graph theory to color it. Register allocation is an NP-complete problem, as far as we know, so it's a difficult problem to solve well, but it's an easy problem to solve terribly. In fact, SSA, which our IR follows, static single assignment, technically has registers allocated. They're just not hardware registers, right? So this is 3, this is 4, this is 5, this is 6. If we just went through and assigned a register to each one of these temporaries, we've done register allocation. The real problem comes in the fact that we don't have infinite registers on hardware. We have anywhere from 3, truthfully, to hundreds, depending on your architecture and your system. x86-64, I believe we have 13 general purpose registers that we can get away with. A lot of those are used for calling conventions and stuff like that. So usually you can only get away with 7 to 10, up to 11, depending on the stack frame kind and stuff like that. But basically, you have to reduce this infinite amount of registers, potentially infinite, into 7. So doing that requires a lot of math and a lot of horrible stuff. You can see that we mark defining uses of virtual register operands. So the first time that v1 is ever encountered, we say, okay, that's a defining use. And then from that point on, in register allocation, we walk backwards. If you want to know more about this in depth, just read this document. I do go very in depth into RA and why it's useful and how it's actually implemented, so I will go more in depth, but basically, we walk backwards over each of these operands, and as we encounter them, if we haven't encountered a virtual register before, we say, oh, v1, we don't know what that is. We haven't seen v1 here or here. That must be a live value. So then that value becomes live in that it is now active. The v1 value has been used and it needs to be defined before it can be clobbered, if that makes any sense, because we're going backwards. v3 is not v1, but it's also not used anywhere in the program, so nothing happens. Then we get to the defining use of v1, and at this point we can say, hey, this is a defining use. That means all we have to do is make sure that v1 is live from here to here, is not ruined or stomped on if we put it in a hardware register, right? v1 has to stay live. It's key to note that we're not talking about like alive or anything like that. It's live, like a wire. Anyway, so v1 is defined here, which means that we can assign a register to v1 and know that that register can't be used again until its last use, aka here. And we automatically calculate that when walking backwards, because everything we walk over, we add to its list of live values. So we have like a working list of live values and go, oh, we've seen v1, we get here and we set v1 as, oh, v1 must interfere with this. v1 is used here, so now v1 is no longer a live value. v0, no, never used, ignore it. Nashiora says, I think I know the answer or close enough, but when do you discard source location information? I assume everything past generating the SSA IR would mean no more errors related to source. Since we're past Lex parse sema, but curious if you keep it for other purposes later. Is it I says, if we had infinite registers, will our CPU go burr? I need a lens GPT. I need one too. That'd be so nice. If I could just map my brain onto a computer and then ask myself things, I'd save so much time. Because I could have like 10 of myself all work together and then concur, like, this is what I think. And then I don't have to do any other thought. I just, yep, that's what I think. There you go. When do we discard source information? Never, ideally. Currently, it does happen simply because, well, no, we technically can access the source because from each MIR instruction, we have an origin pointer to an IR instruction it was generated from. And then in this origin, I think we have the same thing where it points to the AST node that it was created from, as far as I know. That may be incorrect, though. It may be lost at the level of IR, but it shouldn't be. We should be able to keep source location attached to each instruction at all times. So it says IR instructions don't have node pointers, IARC. Yeah, that sounds right. That sounds right. I think I'm just thinking about all the MIR I've just done because it's very much based. The MIR is functions and blocks and yeah. Anyway, after doing register allocation function by function, we can do something fun here too, I think, and look at some of the fun stuff that happens during RA. Beautiful. In this one, it's quite simple, right? We just have v1. Beautiful stuff. We just have v1. That's it. So we collect v1, we find the exit block. There's only one block. It's all so easy in this one. And then we just say, yep, operand, operand, instruction, operand, operand, defining use, removing live value 1. Right? It's never really a problem because v1 can't interfere with itself. It's already one thing, so nothing to do. We just assign a register and move on, right? Which may be a special case that we want to handle. Because that would be a short path, like, oh, there's only one register, assign racks. Get out. Anyway, as you can see, we fill it in with hardware registers, so we replace v1 with r1. And then at this point, we have a move from foo into racks, a move from racks into racks, and then a return. A move from racks into racks is a no-op, so we then have, yes, yet another pass after array, which are the last fix-ups, and there's actually a lot that happens here. So we calculate stack offsets, we lower MIR call to fit calling, not to fit calling convention, that's already been done, but to fit the architecture convention of, oh, we need to actually have the stack aligned properly. And also, there is a bit of calling convention stuff inserted here because we don't know which caller saved registers we need to save and restore until we've done register allocation. But once we've done register allocation, then we can know like, oh, what are the registers in use in this function? And then we can base things on that. If we were doing function calls, this would it'd be very clear. Anyway, calls are complicated and they need to be lowered in code because they're so complicated. They are literally 100 or more lines of C code, right? It's from 1250 to where's MIR call? 1120. So yeah, that's 130 lines of C code. With white space, that's probably 100 lines. It's insanity. Hey, what's up, jelly babies? What a good name. Thanks for joining the Discord. I appreciate it. Welcome, 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 welcome. Anyway, yeah, lots of stuff happens. There's a last step even beyond all of this after array. But after that, also what we do in this step is remove register to register moves. That kind of gets hidden because it's so simple compared to calls. When we move register X to register X, nothing needs to happen. So we actually just remove that instruction, just like we do with the actual unlowered MIR call. And then we just remove those instructions from the list of instructions, and then we are ready to emit code. Chat. We have gone from source code to sequence of tokens, right? The lexer. Then we parse that into a tree of nodes. Then we code gen that into the IR. Then we lower the IR into machine IR. And then we further lower the machine IR based on each architecture through instruction selection and some lowering in code when it gets complicated to the lowered MIR. And then only finally can we actually, after doing all of this craziness, final fix-ups, emit target code. And to do this, it's ironically so simple now, which is amazing. So let's look at assembly. To emit x86-64 assembly, we have these different target files. And if we look at assembly, we have a mapping of opcodes to assembly instructions, right? And then we have some of these helper functions to emit like, oh, immediate to register opcode, because these are all shared encodings of instructions on x86-64. So this just reduces the syntax. I think at this point, we may be able to get away with going even simpler for the assembly backend and just writing a function that converts a machine operand, like the MIR operand, into a little bit of like this one piece, right? And then after we do that, we can just keep appending, oh, for this instruction, append the mnemonic, and then for each operand, append the operand string value. And if there's another operand, print a comma, and then do that. And then you would just kind of happen to build the assembly. Hopefully that makes any sense. But right now we're using these helper functions that build whole lines of assembly because it's easier to reason about this way as well. But I have a feeling we can just collapse this whole file because it's currently 800 lines. I'm pretty sure it could get down to 500. Because I think we can simplify just converting an immediate into string, into assembly string, rather than having to split it up. For CodeGen, we have these helper functions, and then we basically just loop over all the functions, all the blocks, and all the instructions. And then if it's a Leah, we emit a Leah, depending on the operand. So if it's a local ref and a register, then we want to move a local. So if we take a look at one that we actually use, aka move, then you can say move an immediate to a register, move an immediate to a local, move a register to a register, move blah, 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 right? And we have all these different little operand patterns that we match on and then emit code for. And what we're matching on has been emitted by the architecture-specific instruction selection file, so you know exactly what's going to show up because you wrote it. This is the stuff that can show up. And then you just handle these cases. And if you're sensible, you write an else like unhandled instruction, and then ICE and say, oh, unhandled instruction, sorry. And what this will do is basically, if there's an encoding that instruction selection produces that you don't handle, it'll just print it out to you and say, sorry, we don't do that. And then you can go find the place where you need to add it and add it. Is it a use? Can you post a permalink of the document in chat? Sure. That's the wrong browser window. This thing, permalink. How do I do permalink? There we go. We got a permalink in chat. It's a PogChamp. And you just need XE-LaTeX. You don't even need tech. It's a PDF. You're fine. And at that point, we have emitted target code. This is all femit mem to reg. That's assembly, right? So once we have assembly in this file, at this point we have assembly. What I've also been working on, though, and something we'll check out, is the generic object backend. So generic object is this thing I've developed, which is an object file format that kind of shares all of the capabilities of all the object files, kind of reduces it to a subset. Follow up on my previous, because I overthink how people do this for some reason. Lock in int c is just usize, and the AST stores the file name source strings directly. I haven't looked through the rest. Does this carry through and get copied to the other IRs? There's also a note for storing the file's ID index when you support multiple files. At that point, is it worth just storing the file ID in the lock? Okay. Yes. That's basically what we're talking about. Is that once we support compiling multiple files at once, then we're going to need to specify which file it comes from, not just from the source. So with that, we'll just have like a table of files, which is source files, and then we can easily just use the index or a pointer or anything like that from the location. But yeah, that will be pointed to from lock, which is the location struct. Is it Ayush says, thank you, of course. I don't know why I care so much about source storage and source information storage. Brain weird. It's all good. I'm glad you're interested. Anyways, we have these basically generic object file, which just has a bunch of vectors, a vector of sections, a vector of symbols, and a vector of relocations. And with these, we can produce actual files, which we can take a look at, actually, because I wrote a nice little printout for them, even. Yeah, look at this. So all I have to do is print this bad boy out. So if you just type -t's into the compiler, I screwed up spaces, God. If you type -t's, then you can see that these are all the different targets supported. When you type -t, you need to supply a target. Yeah. You can't see it, but it says expected target after command line argument -t, which is one of these. Anyways, let's create a cough object, because we're on Windows, called code.object. And look at this. We now get a GObject dump, where we have a .text section, which is 16 bytes. And this is the actual machine code emitted. And you can see we have the object dump style for the machine code, because you gotta view strings, right? Gotta be able to see strings. Anyways, this generic object file has a data section with a OX45, which is 69, POG, E. And then foo and .data at offset 0. Foo is 69. Would you look at that? In little endian, which is x86-64's encoding, so that's good. And then we have main, which is a function defined in .text at offset 0. So this is the main function. Poggers, huh? C3 is ret, 55 is push RBP, 48 might be, it's a move, because this is a rex prefix followed by 89, which is a move, and then, yeah, operands. Very cool. The mod RM byte, that's what it is. Same here, but this is, here's something very valid. See these 4 zeros? And then there's a relocation of foo in .text at offset 7. 0, 1, 2, 3, 4, 5, 6, 7. So at offset 7, there's this relocation. So these 4 zeros will actually be replaced with the rip relative address of foo. And that will be done by the linker, not us. You can also use object dump on this and also see the same thing. We have 0, the .text section, which is 55, 48, blah, 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 right? 89, E5, and then here's the relocation. We have 7, which is foo. We're referencing foo here in this relocation. And I think, what is it, T? Yeah, and then you can see foo is a symbol defined in this object file. Cool, huh? And then this, as you can tell, is very similar to the assembly, because this is the disassembly of our machine code. Anyways, all we have to do is pass this to a linker that works. I'm going to use GCC because I'm on Windows and user space programs require a ridiculous amount of work to get working. If this were Linux, I could use LD. But we're not there. So I'm going to use GCC on code.object and produce code.exe, which I've done before. I'm going to run it, and you can see it returns 69. Thanks for listening to my TED Talk. Is it uses Yeah, there's a lot going on, I know. This little bit in the end requires a lot of running knowledge, but you gain all of this as you learn programming. You build it slowly. If you see it all at once, it is scary. But yeah, as you can see, we have code.exe, and we can even object dump, here, I don't want to do that. And then you can see that relocation has now been resolved. So you see these 4 zeros are no longer 4 zeros. It's now an address, BAC5, off of RIP, which is 14,000 D0 D10 D010, but which is the address of foo, which the linker chose to put foo. So basically, the linker's it's not a complicated beast. It goes through all these relocations and says, okay, foo has to go somewhere in memory. Foo has a definition, and it's within, right? If we look, foo has a definition in .data at offset 0. So go to .data at offset 0. That's the address that we need to fill in here, but it's rip relative, so you need to also know where this code goes first. Don't worry about that. In the code, it's C5BA0000, but in the assembly, it's BAC5. Is this something to do with Endianness? That's everything to do with Endianness. When you write a number, 45, right? Let's say you have the, here, let me get to an actual scratch buffer so this doesn't look crazy. If you write a number 45, the largest digit is the most significant one, right? So when you read 4, that doesn't mean the value 4. That means 4 tens. But when we read 5, it's the last digit, right? And this last digit is less significant than this digit. It's a tenth, right, of the last digit. This is what's known as Big Endian, which is a reference to Lord of the Flies, I'm pretty sure. But what it really means is that the big end of the number comes first. Okay? It's not more complicated than that. When we as humans write hex numbers, as humans who speak English and use Arabic numbers, we also write them Big Endian, because that's most natural. Right? So if this was 69, this would be OX45. So 4 doesn't just refer to 4, it refers to the hexadecimal digit 4 in the 16s place, right? This is 4 16s plus 5 1s, because this is a base 16 number. This is 6 10s plus 9 1s. And if we do this little calculation, we can. So multiply 16 by 4, and then we want to add that. This is Lisp, don't worry about that. I'm just calculating something. And then we add 5, right? Whoops, totally screwed that up. I didn't actually calculate it. So we add the multiplication of 4 16s plus the multiplication of 5 1s. And we get, believe it or not, 69, or hex 45, because that's how this number representation works. Yeah? This is not how x86-64 computers work, sadly. x86-64 computers are little endian, and little endian means that the little end of the number comes first. So that would be like if we wrote numbers like this. This would still be 69, because there's a 6 in the most significant digit, and then there's a 9 in the least significant digit. So in little endian versus big endian, these are both equal. But here's the thing. That's not quite how computers work. Is it Ayush says, who decided this? We'll get there, we'll get there. That's what I'm doing right now. But why would we do this? This isn't how computers work. We don't store decimal digits. What digits do we store, everybody? What type? They're not base 10 decimal digits. Binary! Hey, Taxborn. Nice. With the quick answer. It's binary, right? We store base 1. Not base 1, base 2 numbers. And here's another thing. Machines these days are byte addressed. Byte addressed. You cannot read a single bit from memory. Yeah? You must read multiple, at least 1 byte, usually. Sometimes it's more, like on RISC-V, you have to read 4 bytes at a time. And then do bit shifting to get your values. So you must read multiple bits. Yeah? So to read multiple bits in a byte address system, that generally means you can only... data is at the byte boundary, right? The smallest bit of data you choose is a byte. Which means that in this number, it would still be 0x45. Because, if you don't know, each digit of a hex number is a nibble, which is half of a byte. So 2 nibbles equals 1 byte, 8 bits. This is the first digit. So it doesn't matter what happens. 0x45 in big endian or little endian is 69. Where this comes into play is in a bigger number. Let's do a number like 420, right? Is that O1A4? Is that what that said? Can't read. Yeah. Hex 1A4. 420, right? So 420 in decimal little endian would be that. And in hex little endian, again, it's byte address. So the first most significant byte, if it's little endian, has to go last, right? Oh, wait. This is A401. But the number that we would actually write as humans would be 420, whoops, and OX01A4, right? These all look very different. So a computer being byte addressed means that the bytes of a number, it matters what order they're in, because you have to access them and decide which digit goes where. So is the first binary digit 2 to the 63, or is it 2 to the 0, right? You have to define that in a computation. And to do that, it's big endian or little endian, which is just a reference to Lord of the Flies. Have you ever read that book? Some kids eat their eggs differently. Don't worry about it. Lord of the Flies is a hard book to describe in a short while. Anyways, all of that to say, this C5BA00 is a little endian OXBAC5. And these zeros are leading zeros. This is 0000BAC5. So it says it's a reference to Gulliver's Travels, actually. Is that what it is? It's one of those old books, man. I read like Treasure Island, Gulliver's Travels, Lord of the Flies. I read all of these in like a year or two, and I don't remember the difference between any of them. They're all the same thing. And also, what's that other one? The one where he goes to the island to be, and then he meets the cannibal dude. Robert Crusoe? No, I also read that book, but that's a different one. So it says 17th century, 18th century, 1700s. Whoever did that, I want to strangle. Whoever made the 18th century in the 1700s. I understand that, like, that's also how computer indexing works, but we're humans. We're not computers. Can't we just simplify it a little bit? The 18th century should be in the 1800s. And the first century should be the 0th century. I know that's a contradictory statement because English doesn't work that way, but come on. Thanks for the big little endian talk. I wanted to check my understanding, appreciate it. That explanation to why really helped. I'm glad. Hopefully it'll help a lot of people. I hope. Let's actually implement something like discard. I'm getting itchy. So we're going to add a new keyword to the instruction selection grammar. Discard. I've actually already added it to the grammar because I've got a lot of stuff to do. And I know that. I still haven't set up the BNF mode. I'm so sorry, Saraid. I feel so bad. I have it just sitting on my computer, and every time I open this file, I cringe. Anyways, discard. It's a keyword. We should be able to just add it to this match pattern. So whenever we're... Do we want to emit discard? We probably want to do something like this, actually. That's going to be much... Yeah, that'll be much better. So we're going to emit or discard a matched pattern. Yeah. So what this will look like in practice is here. Where's our discard ones? We need to discard. Where are the discard ones? Here they are. These are the ones we want to discard. So we need... Yeah, I think that makes sense. And also, of course, the editor. Keywords. Match. Emit. Discard. That's not what I meant to do. I meant to load file. Editor, ISL mode. Beautiful stuff. We have discard now. So it says just add it to your .emacs. It's not a bad idea. It's not a bad idea. At this point, I mean, I'm desperate. By the way, don't worry how I've done this. It's a stupid optimization. It's not really worth it. I'm probably going to get rid of it. Anyways, we now have a bunch of places where we have errors because we're not populating switches. So let's add this. Return discard. Make sure it's with the other keywords. Not discards, discard. So we can now turn that token kind into a string. Beautiful. What else do we need to do for an ISL token? We need to add to the keywords. So we just have this little static array here. Should probably be a tree or something like that. Prefix tree, but it does not matter. See, I always want to see tree or prefix try and not try and prefix tree. I have those messed up. Because English predates 0, if you will. That is true. Pretty sure the other book you were talking about is Robinson Crusoe. Yeah. That's the one. That's the one. Man, you just flooded back a bunch of memories. Which, of course, is not the full title. The full title is like 100 words because it's so old of a book that it also includes what would today call the blurb, lol. Like what we put on the back of the books today. Anyway, new keyword. Now what's going to happen? Everything should blow up. Perfect. It blew up. Expected identifier in order to parse a general MIR opcode. I don't think that's general MIR. I don't know if that's proper, but it's expecting something, and we get discard. Yeah, we just want to parse an opcode. We don't really care that it's general here. Might be. Cool, so we parse an opcode. And the reason we're trying to parse an opcode is we're trying to parse an instruction specifier. Yes. And the reason we're trying to parse an instruction specifier is because we haven't hit the emit keyword. But we also don't want to hit the discard keyword. Yeet emit / discard keyword. I think at this point I can do this. Beautiful. So yeet emit / discard keyword, and then parse either a single instruction to match in the pattern. But if we are at a discard keyword, we want to keep the output empty. We don't need a closing brace. You know, we should be able to just... Let me think about this. Do we need to... We almost need a go-to here, sadly, but what I'm going to do is just flip this condition. We want to say, yeah, this will work. If we get the emit keyword, then we want to parse either a single instruction to match in the pattern or an opening brace, and then until the closing one, or... Yeah, but if we get the discard keyword, we don't want to parse anything. We just want to leave. Expected match keyword at beginning of match. Did I not yeet the keyword? Oh, okay. Well, the interesting part here, I've called next talk before I've checked the token kind that I need to check. That's annoying. That's very annoying. So we just need to do this later. Yeah, it's not ideal. Because this is going to be in both the if and the else. It's kind of cursed. So now we can omit the discard keyword and the omit keyword. We now know which one we're discarding. So that's useful. Hey, it worked. PogChamp, PogChamp. I don't know if this worked. Let's try and remove that static reference that we're not using. Don't need to name these. Hey, poggers. Folks, that's what we like to see. That's what we like to see. Ooh, there's so many warnings for things we haven't provided. It's a work in progress. That's poggers. So now this static reference on x86-64, we can just use foo rip addressed. So we never actually need to load it into a register or anything like that. Other than if we're going to load it into a register. Like if we're going to add to the pointer, then we'll already omit that load. So we should be fine. Because if you just add a static or to something, then that would be different. That would be the value of the static, right? To actually get the pointer, then you'll do an address of which will produce a register. Everything's fine. We can remove static reference. And we do. We get rid of that entirely. So now we just have move, foo, and ret. How beautiful is that? Is that really what we have? I guess we have to look at the object dump. That is. We have move, foo, and racks, and then the function entry and the function exit. That's it. That's poggers. Very nice. Okay, well, there's the discard keyword. That was surprisingly easy. Megit took a long while, which it normally doesn't. Oh, because I have a bunch of unsaved files. It's going, why do you do this to me? That includes you. Thank you so much for the follow. Okay. We can get away with never omitting these, as they should be inlined as operands when used. Cool. That. How about that? How about that? Oh, ow. Oh my God. Okay, this might be TMI. I just rubbed my face and I got such a sharp stinging pain from a giant pimple that's forming under my skin. That hurts so bad. That was amazing. I was like, what is stabbing me? It's like a bee sting in the face. It's like, oh yeah, you just rubbed your skin, which is destroying itself. Ah, programmer life. Drink more Mountain Dew. And everything still works. Fantastic. If I really wanted to, I could run the test stuff, but I don't want to do that. Why do I have Arch x86-64? What did I not save here? 45 thing. Yeah, we don't need that. That doesn't matter. And then code.s, it should never care about. Beautiful. I have so many untracked files. There's too much stuff. It's getting complicated. Okay, let's just go through. That's right, I changed that styling, it's fine. Ooh, pretty. Yep, that's fine. Okay, this is where we're at. We added discard. Oh, I have unpushed. Unpushed commits. Let's push those. We have generic print object. We don't need to push that. We do want to push this once we have discard, but probably after we implement discard. Oh yeah, we no longer emit all the static variables at the beginning of a function. Because that was a register allocation thing. And, yeah. Yeah. Okay, so at this point, we're down to just our changes in instruction selection. We have a new enum, keyword discard. We want to convert that enum into a string. Yes, we want to parse that keyword as part of our parsing, or lexing, I should say, lex that keyword. We fix this little error message. We'll include that. We've altered the grammar to now have a discard keyword option. We've altered the code to now have a option like this. What's happening here? Git is messing with me because this is the same as this, but with 2 more spaces. So this is just indentation. Git being weird with indentation. So let's stage those. Yeah, that makes more sense. So down to here. Yep, we can just do the full thing. And we don't need my little special warning for myself. That's fine. We definitely don't want to keep that. Okay, we'll do that in a separate commit for RA. I didn't realize I had that change. Okay, so that as far as instruction selection, that should be it. And then we can do the Emacs mode as well. I'm so tired, I'm sorry. I'm slowing down. I'm slurring my words. I'm just gonna okay. ISL, instruction selection. Add discard keyword to throw away certain pattern. Yeah. To emit no instructions for a given pattern. Beautiful stuff. Yep, beautiful stuff. Where are we at? Where are we at? We want to actually use it now. So we can get away with never doing this. We also have the maybe incorrect check. And then I did this differently. Oh God. So multiplying an immediate to an immediate. I multiply into a new temporary. or move into a new temporary, and then multiply that new temporary by... See, but I1 never actually ended up with the immediate in it, so that's incorrect. I think this one's... yeah, I don't know why I did that. That's definitely wrong. Oh, I was testing. That's right. That's right. You'll notice that was a multiply, and what I had done is taken... Yeah. So I was testing that you can take an I1 and then also do I2 somewhere else. For example, in the output, because referencing an input instruction and an output instruction is very different, and how you resolve those references is different, and all that stuff. I remember when I was writing that code now. I added that. Okay, so now ISL, we take advantage of the discard stuff, which means we can also go get rid of these no-ops. Exactly. To do, remove these. They'll be here until we get discard and instruction selection. We did it. We did it, chat. Okay. Poggers. Okay, I thought this was a fall through. Yeah, we definitely need to separate IML from add, because IML has a 3 address. Things are not ideal. Man, that's a real chunk around my face. What did I just change? Oh, that's what I was doing. Okay, so I did the generic object file backend. Presumably, I need to do the assembly backend now. Static ref? No? Okay, yeah, here they are. It's copy and paste it. Look at that. How beautiful. Alrighty-dighty. And now we have removed these. Beautiful stuff. Beautiful stuff. Is this incorrect? Let me just look at this. Move over. Move. So when we have a move, from source I1 offset, so this is going to be a register immediate. Can we look for... Well, first of all, there's going to be 3. And then it's going to be register immediate. What is register immediate? That's this one, right? That's reg to mem. Reg to mem. So when we load a register, shouldn't it be mem to reg? Which is register. Yeah, I think this immediate's in the wrong spot. This should be fine. Should be pretty simple to fix. Not this one. Is it that one? No, this one. Yeah, look. Yeah, hold on. This is easy. We have a store here, which gets its instruction selected into a move from an immediate register immediate. So we know that it takes 2 operands to have a memory x86-64 single memory operand, a register and an offset. So if the destination here followed by an offset means we go immediate to mem, oh, we go static to mem, oh, shouldn't the idea be that we're loading from an address register? Which means that we actually want to dereference it. Vegan. Welcome back. What's up, vegan? It's so good to have you. I like your name. You always make me smile. This isn't x86-64 assembly, but it represents it. This is x86-64 assembly. I don't know necessarily which one you're talking about. This is a custom DSL for the compiler that I've written for instruction selection. And this is the x86-64 instruction selection file, but this is not assembly. It does have to do with building or omitting opcodes and operands for x86-64. So to answer your question, no but yes. Okay, that's proper. I'm just gonna commit that. And now we can say x86-64 instruction selection, take advantage of new discard keyword. I kind of also want to add that other thing I did. I said take advantage of the discard keyword, remove old no ops when we had to just ignore instructions that should be discarded during ISL. Also fix a bug with the MIR load register pattern, as we need to have a mem to reg form, which means register address, immediate offset, register destination, operands. Cool. I feel like that's a much better message. What else do we have? We can push those changes. So, woo, they're here. Where? Here. Perfect. 10,001 lines. It's so much. Okay, now these are comments. This is a static versus not static for an unused function. Doesn't really matter. This is an actual simplification where we use a macro instead of doing it manually. We'll do that. Moldy the Man, can the compiler create exe files now? It can create object files, so it's close. In truth, it would be trivial to write exe files if we didn't have to deal with any system stuff. So like if we could just write, like writing a linker at this point wouldn't be the hard part. No, that sounds crazy. The hard part would actually be getting the linker to produce something that the OSs then will accept. But getting it to just produce an executable file that's technically correct and can run on like Linux that doesn't call any functions or doesn't link with libc, doesn't do any of that. That's easy. If we can produce executable files, but it wouldn't be helpful because then you couldn't link anything with those files. It would just be in this thing that sits there, right? So the idea, let me write this commit message before I get distracted forever. Use for each of my operand macro instead of doing it manually. What else? Warnings. We removed this. Surade's gonna get mad at me for removing this. I don't know if I want to commit that yet. I want to think about that a little harder before Surade roasts me. So we can produce all of the following targets currently, and they're not all fully supported in every test working, obviously. It's a work in progress. Assembly is the default, and this is just GNU AT&T syntax assembly. So that would be in code.s. So if you pass nothing, it'll just spit out code.s, which is assembly. And then you can use something like GCC code.s, and then you can make your executable, and then you can run it. But recently, we've also had a large stride in that I also support elf and cough objects. So we can do a cough object, and then we can even object dump this, and you can see that here we have machine code that we've encoded in the compiler. We have relocations that we've inserted for the linker, and we have, basically it's ready to go. All this code is ready. So you could in fact pass code.object to anything, and then pass like main.c, and then you could ideally, not main.c, but like code.object, and then some library.c, and then -o code.exe, and then everything would work, right? And that's actually what is happening, because if we take a look at -v, right? This is what I talk about when the hard part isn't linking, it's the system, libraries. So if you take a look, just to make code.object into an executable, first of all, there's link time optimization for GCC. Don't worry about that. There's none going on. Most importantly is this little GCC options. You know, this is what GCC calls min-GW GCC, right? This is what it passes to actually be able to compile all of this stuff. So we have, for example, -l min-GW32, -l GCC. So we link with libgcc, with libmin-GW32. We link with pthread, we link with mold name, we link with min-GW extended, we link with MSVC runtime, we link with kernel 32 from Windows, we link with pthread again, we link with user 32 and ADV API 32 and else shell 32, and oh, also, why not libgcc again and libpthread again, and also min-GW extended and kernel 32 again. So we can just, all of these, we're going to have to magically like know for each system. And then it gets even worse because we then have to go through and actually figure out how to link all those crazy things like dynamically linked kernel DLLs in Windows and libc shared DLL. It's like, nobody wants to deal with any of that. The hard part is all this stuff. The actual linker part that like, oh, there's a relocation. Where is foo? Fill in the address of foo in this number. It's like, that's easy. The hard part is all the systems. Yes, we're doing all of this without LLVM. There are no third-party dependencies for this compiler. If we take a look at the CMake lists, it's quite simple. We have an executable, an include directory, and some tests. There's some options for like warnings, and some tests. That's really it. There's no dependencies. There's nothing extra you have to download. There's no submodules. There's nothing. Yeah, there is libm. You do need libc and libm, but those come with every OS, and if they don't, your OS isn't complete. Because even Lenser OS has a libc and libm. And Serade wrote a LLVM format checking plugin, but we don't actually link with it or anything. It's a separate program that runs as a plugin with the when you're running Clang. And this actually type checks our custom printing. So for example, eprint, you can see we have all these specifiers, and it'd be nice to know if any of these types mismatched, and that's what that does. I can't get LLVM to work or any of this to ever work, so so if you can, let me know. But that's why there's no third-party dependencies. We do it all. And the object files are honestly pretty easy. Just made this like generic object file format. Because it doesn't need to be serializable. At least not right now. So it can just be in memory. Yeah, sorry with the details. To be able to use that plugin, you need certain static Clang libraries, which pretty much means you need to build LLVM yourself for that. I cannot do that. That's not the case if you just want to use LLVM for generating IR, etc. But for the plugin, I see there's no way around it, but I could be wrong. Yeah, compiler plugins tend to get deep. Anywho, if anybody has any questions, let me know. I am happy to have gone over everything, and I had a ton of fun today, so thank you. I don't have a ton of time, which probably means 3 more hours. I do have a to-do list. Let's look at that. I think I can set one thing to done. And I just noticed another thing in that to-do list that I've finished. I'm pretty sure I've handled both of these things. Okay. Now, where are we at? Discard keyword. Yes, discard keyword to have a match pattern to mint nothing. Nice. Yep, that's done. Whoops. Onde. Cool. Is keyword to ensure value equality between operands. Yeah, that's going to be a complicated one. Nació donde está Santa Claus? La biblioteca. But yeah, it would be really nice to be able to compare operands to each other. That shouldn't necessarily, I mean, it's going to be difficult, but it's not going to be too difficult. The reason it's going to be difficult is because we have to represent this relationship somehow. Like, in this operand, it would normally just be itself or have a value. But the fact that it has to be, like, equated to another thing means that this doesn't just have a value, it has a value plus a list of things it needs to be equal to. Beware the chimney man. Saving restoration of Kali saved registers. I don't think we're doing that at all. We can take a look. Yeah, we're not. So, to do. Save. Kali saved registers. But are we close to generate exe files? I don't know if that's ever the goal. We're emitting object files, which is kind of as far as I want to go. Because we have elf and cough object files, which means that GCC knows what to do with them and stuff. Because if you do GCC with the same thing, you can see we get very similar things, right? And both of these can be used by any linker, really, to produce an executable. So, and the linker isn't the hard part. Again, we could write a linker in like a week. The hard part is all the systems libraries that we'd actually have to support and link with. Because again, GCC is not simple. There's all this garbage going on. Like, oh yeah, let's just fix up the system include headers, and then oh yeah, let's just I don't even want to get into it. You're giving me Lenser OS nightmares. So it says, yeah, that entail writing a linker, which would be a massive pain because of all the aforementioned system depth nonsense. That just reminded me that Last Christmas and Santa is a thing that exists, and I'm partially responsible for it. That's right. I forgot about Santa. Ho, 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 ho. It's a fun one. Yeah, save Kali saved registers, and then go after this, please. To do, restore Kali saved registers. Beautiful stuff. Just as an example, Molly the Man, this is a linker. We take in some relocations, we go through and determine where they're actually placed in memory, and then we replace the value in the actual code with the new value that we've calculated, the relocation. This is manual linking, right? All these local things. Because there's no need in the object file to have like each basic block get its own symbol. It's kind of verbose. You really just need a symbol per function, and all the basic block stuff can be merged. I am local things. That's a good point, local. That's me you're talking about. So we definitely need to do Kali saved register stuff. Re-enable instruction-specific hardware register interferences. That's right. So, and everywhere that this is commented out, somewhere that this is commented out. Like here, we need to set the instruction register interference based on the instruction. But we need to do this in a different way. The way we're going to do this is that we're going to have in ISL an optional, basically we're going to extend the ISL grammar to include in a match pattern, not a match pattern, an instruction specifier that there may be a like clobbers keyword, right? It may clobber. And then after that, there may be any amount, I should say one or more. There should be one or more of probably operands is how we're going to parse it. I don't know. We'll have to think about how we're actually going to specify this, because it's just going to be identifiers. Followed by some amount of identifiers. Which then, how do we know when we get to the end? So we're going to need some like terminating clause on this too. It's like we put a semicolon after it. Or I guess we could use the comma, but I don't like that. Hey, hair hot Zen plots with the raid. What's up? How's it going, everybody? We are doing it. Oh, Pan Spinning Kids is raiding with a party of 6. How'd you get 6 people on there, Pan? That's awesome. Haven't you been watching this whole time, Pan? Are you streaming too? What's up? First time chat. Dr. Honey, what's up? Thank you so much for tuning in. I appreciate it. You might want to PA insert BNF mode, Lamau. Strippitum says, wow, this is tough. Oh, you can't deal without the syntax highlighting, huh? Her Hudson says, just rated in because I'm tired and had to stop messing around. That's exactly where I'm at. I went through my entire compilation PDF today, which is good. We got through the entire new control flow of the compiler. Pan Spinning Kid says, whoopsie, no, I just watched the beginning. Well, I appreciate it, Pan. Thank you. Stirpy Time says, damn, is this public? Of course it is. All of my projects are free and open source. You can find them on this particular one on GitHub. I think it's the MIT license. Yep, MIT license. So it's literally a do whatever the hell you want. Strippy Time says, thanks. Of course, of course. Be sure to join the Discord. We talk about this compiler all the time. We have an amazing community of people, and we'd love to have you all here. What was I doing? Oh yeah, instruction selection. So with instruction selection, I was thinking about how is going to work. Oh, and also, yeah, clobbers as well. So with clobbers, yeah, we're going to need some semicolon ending thing for the list of clobbers. Otherwise, we'll have no idea. It'll just be an unbounded, ambiguous grammar, and it's horrible. Oh, Sarade with the link. Nice. Totally forgot. That's probably a good idea. First time chat from Triffy. I need to find my dragon book. Oh god, no. And play with compilers at some point when I want to lose my mind. Yeah, that's pretty accurate. That's pretty accurate. So we're just going to have... Maybe this should just be operand as well. Because that is just an identifier, but it may also be more than that. So you could say, we'll go with that for now. So an instruction specifier where we have an opcode followed by the name of the instruction, which is actually optional, followed by parenthesis, followed by one or more operands. There may be none, so 0 or more operands. And then optionally, we'll have this extra clobbers operand, possibly one or more operands, concluded with a semicolon. Yeah. So it says we should probably on intercept command whenever we had a Twitch bot. Lol. That's a really good idea, so people can get the link. Vision for All, the Major, thank you so much for the follow. Stage 3 Ghost. Oh god. That's better than a Stage 4 Ghost, I guess. So it says, to be honest, the Dragon Book is a bit dated nowadays. A bit! Like, e.g. the entire section on LR parsing is just not relevant at all. Unless you're writing a parser generator, or a Lisp parser. Should also add what the fuck I don't know command, so people don't have to know it's a lang called intercept. They can just what the fuck I don't know, and it'll be like, oh yeah, this is a lang called intercept. Stribby Time says, I suck at compilers so bad I failed to implement an interpreter for a piss easy DSL because of an include operation. Kick. None of that sounds easy, to be fair. DSLs are not, like, simple. This is literally magic. It's not, I promise. It's just math, mainly. Oh, okay. So, clobbers. So this would be like when we have a move instruction or a store instruction. So let's think about something that would actually clobber, like return. Not return, because that's handled by the calling convention. It should already be set. So we don't need return. We need div. We don't even have div in here. We want to match, let's do a register to register divide, just to think about this right now. And then what we want to do is divide these. Kind of matters. And then this is going to clobber racks and RDX. So it says, oh god, div, we definitely need the clobbers for that one. Yeah, that's what I was thinking about. So it says, honestly, I can't think of a single book that just talks about everything, but I guess people like crafting interpreters, I guess. And the SSA book. SSA book is deep, but if you have like a logical mathematical background, it will help you immensely, I'm fairly certain. Or just wait until you're a month into compiler development, then you'll need the SSA book. Personally, I don't like crafting interpreters. I didn't find it like useful, but I don't think that means it's not useful for anybody. I think it's just that I don't learn in the same way that he teaches, if that makes any sense. Okay, but yeah, we're gonna need something like this, right? I mean, anything is better than the LLVM tutorial, at least. Ugh. The Kubernetes kaleidoscope kickoff. Nashiro says, it's great for getting to know Lang implementation terms, how to get a front end going, and how interpreters work. That's fair. That is probably very true. I think by the time I read crafting interpreters, I already knew too much of that for it to be useful. But if you're right, if I read that with no experience, it probably. Crafting interpreter is a good entry level and gets you asking the right questions. That's probably true. It's probably very true. But yeah, so we need something like this. And then obviously we're going to need the ender, because how do we know it's not just another identifier for an opcode? We need to actually terminate this clobbers list, which means it may be easier to do in like this. Interesting. So what if we just put like a clobbers list like this? Nashiro says, I go get ready for appointment thing. Have fun rest of stream. All right, local. Thank you so much for hanging out. It was amazing having you. To have good luck at your appointment. Hopefully you're on time. Be safe. Bye-bye. Sarid says, it links me to it if I search that, but the actual title, as far as I know, is literally static single assignment book. Yep. At least that's what on the title page of the PDF. That may also just be a working title. But yes, it is absolutely... I'm pretty sure the SSA book will pop up if you Google it. Hope I get Social Security. What a static single assignment. That's what it stands for. This is what we'll get at. Yeah, here we go. Lots of authors. Beautiful. The book. Phi. But yeah. It gets into it right away. I promise. It's very useful. Oh man, this giving me flashbacks when I first learned about phis. It makes me want to cry. But yeah, it's good. Good stuff. Good book. Very complex, so if you're like looking for entry level, it's not that. That's like compiler level. Radar, Triffy, I had a red team friend who went way too deep into LLVM to obfuscate his malware. I just wish it didn't break everything with major versions. Lamau. Taxborn says, appreciate the resources. Nice, and Stroopy Time has the link to the book. What a legend. I think I might just want the keyword. I think that is... This is fine. Yeah, this is fine. By the way, is there even a register to register idiv? Am I making this up? Let's look. we're in imul. Where's idiv? B, C, D, F, G, H, I, ID. There is no register to register idiv. Legendary. Sign divide, EAX, EDX. Okay, so what we're going to have to do is zero out a register, presumably, which is racks. Right? So we have to zero out this register racks. We have to move the left-hand side into racks. We have to divide by the right-hand side. And then we want to move with racks into I1, our result register. So we zero out racks, EAX, technically. We move left-hand side into racks. We divide, which clobbers racks and RDX. Strippy Time says, I just got confused by results. The result register or by the book title? Umit Ildrum. Thank you for the follow. What a name. Strippy Time says Google results, sorry. Oh, it's all good. Just want to make sure if anybody has a question, I hop on that. I think this is nearly the basis, but here's the thing. We're zeroing out RAX, but we're not zeroing out RDX. And if you'll notice, we're dividing RDX, RAX as a bit field. So what we're going to have to actually do is, the problem is if this number is negative, we need to actually put that in the top bit of RDX. Luckily, or somewhat luckily, x86-64 has an instruction for that. I think it's called Cuckoo. Might be, here is probably the quickest. Cuckoo. Beautiful. So, convert word to double word, convert double word to quad word. Basically, we want to say RDX RAX is equal to signed extend of racks. That's exactly what we want to do. That's just a cuckoo. We can just emit a cuckoo. Like that. That's a good point, pan spinning kids. This should be a div. Don't worry about that. So we match a divide instruction of register left-hand side by register right-hand side. We zero out EAX. We move the left-hand side into racks, which technically means we don't need to zero out EAX because we're already going to write to racks. We convert quad word to octal word. A word is 2 bytes on x86-64, which means that a quad word is 8 bytes, an octal word is 16 bytes. This does the racks to RDX sign extension thing that we talked about, which means that in idiv, we now have our number, our signed number in RDX racks, in which case, with results stored in racks quotient, RDX remainder, in which case our quotient is in racks. And then we have, by the way, if you ever wonder why multiplication or division is slow, do you now see? It's hard to even code gen properly. And then we also have our mod, which we're going to want the same thing, but we move our DX. Div mod, something like that. So it's, what are we at? Strippy time, dedicated sign extension instructions. Oh yeah. Even better, dedicated sign extension instructions, but just from racks to RDX. Yep, hard-coded. They take no operands. Just does this one thing. It's how it is. x86-64 just did that. Said who 13? What are you doing? I don't know. What are you doing? We're doing a lot. We're doing a lot. Anywho, this is good. This would basically be the formula. Because this clobbers racks and RDX. We would already know that this clobbers racks because there's a use of racks here. And then another thing I didn't mention for this is that it's going to make register allocation more complicated. Because currently when we're collecting interferences, here, you can see that for each instruction in reverse, then for each operand, if it's a virtual register operand, then we set the adjacency and make it a live value. And we set the adjacency for all of the live values, sorry. We don't set the adjacency here. We just add the live value. But the problem is we need to start doing this not for just virtual registers, but for hardware registers as well, because hardware registers can also be live and need register allocated. I don't think we need the semicolon after the clobbers clause. The comma should be enough, or rather the absence of one. The commas are optional in the current syntax in every case, and I don't want to change that. Because you could just write everything like this. So it says, yeah, you and optional commas. Yeah. No comma operator overloading then? This isn't the language. This is a DSL that's used as an implementation for the compiler. The language will have, I'm sure it'll not have an optional comma type thing. As you can tell by the C-style for loops. But these are optional commas. But yeah. I don't think there's any reason we couldn't overload it. It would just be, yeah, because this would just be parsed as comma operators instead of flat. Imagine not allowing overloading the comma operator in your ISL table format, F. Imagine in 2023. Okay. So another thing that I think I screwed up is that this register racks that we're moving into, I should probably name as dividend. The dividend, the dividend goes on top. And then we want to move dividend. We want to move racks into I1. Do we need to do this? Why would I do this? See, my problem is that racks technically isn't live here. Because it's a hardware register. And we can't, like, do liveness analysis of hardware registers. Can we? No, because there's no proving that one access of a hardware register or another one refers to the same value and that it hasn't been defined already in between. But yeah, that's something to think about for sure. So basically, for each MIR operand, what we're going to end up doing is probably just this. We're probably going to have an extra vector of operands. Right? This is going to be clobbers, but it's not going to be an operand vector. It's going to be a register vector. This thing. Should probably just make a typedef like this. Sure. You using LLVM? No. No third-party dependencies. Pure C. For idiv, I think you have other flavors that don't need extension, don't produce the remainder, but can operate on other registers. Yeah, pen spinning kids? Would you like to take that up with the Intel manual for x86-64? idiv, sign divide, with these operand encodings, of which they're all memory? These are the only idivs. You might be talking about div, but that's different. That's an unsigned divide. And we'll give you different answers. And it's also not different. Div is also the same. I tried to give you the benefit of the doubt, but it's not. I think you are thinking about imul, most likely. Imul does have more things. If we take a look. imul, you have 3 address multiplication between immediate and register memory. And you also have register to register multiplication and stuff like that, which is new in x86, but idiv still sucks. Cool. But yeah, we're probably going to need like a list of clobbers like this. Yeah, LLVM is a pain. Pan-spinning kid says, nope, imul. Yep. Oh, nice, nice. Strippy time. RISC-V CodeGen when? Whenever you want. Feel free to make a PR. It'd just be another backend. It wouldn't really be that complicated. Right? It's just a lot of data entry. Like how to convert. You just need to write the ISL. Right? To convert a divide into whatever you need to do on RISC-V to divide. And then write the driver, which really just emits everything. It's not too difficult, really. Strippy Time says, to be honest, I might try that. Thanks. Of course, that would be awesome. Even if it's not like 100%. Like you don't have to support every single instruction right away, right? Progress is progress. And having more than one backend, I mean, I can't like test RISC-V stuff. I don't have RISC-V a RISC-V computer to test things out on. I could use QEMU, I guess. It's not a bad idea. Why is this indented by 4? Jeez. Okay, we're good. We did it. We did it. We, in the machine IR, we want to have these clobbers. Then we want to add to these clobbers. And then instruction selection. We're going to make sure we want to MIR make copy. Copy this vector over. We're going to do MIR, not compile, comp mode. Not comment mode. Emacs. Okay. MIR. Yeah, I'm an absolute buffoon. This needs to go in MIR instruction. Herpaber. And then we can't just do this because this is C. I think we have a macro for this. Yeah, we're using it right here, literally. In which case we want to take clobbers. Strippy time says QEMU. I mean, I have an OS. If I can emulate x86-64 with QEMU, I better be able to emulate RISC-V of all things. Dr. Honey says it's complicated because RISC is load and store. Why would that be complicated? LDR and STR is just move. Right? Am I wrong? Maybe I have a fundamental misunderstanding of RISC-V. Go WebAssembly and you could test it in the browser. That's true. That's also doable. I found it quite easy to write an emulator. Emulators for simple architectures are quite easy. So it won't be that bad, probably. Every part of it was horrible. Okay, so we now copy clobbers when we make an instruction copy. That's fine. And then in register allocation, what are we going to have to do? So for every instruction, we set its live vals, question mark. Somewhere. Okay, here's where we add live value. Here's add set. Okay, here's where we set the interference in the adjacency matrix for each live val. Okay. And then just above the, yeah. Okay. So then we also want to make this value interfere with all clobbers. And basically, Panspin Kid says, it is indeed. Oh no. So basically, we will have clobbered some register. And we want to basically say adjum set. So we need to do this type of thing. Could not find vreg from clobber's list in list of vregs. Okay. And it's going to be clobbered. Get index of clobbered virtual register. Not even a virtual register, just register. Get index of clobbered register. And then we want to set in M or something. Is this how we did it? What's it called? G matrix. And we want to set the instruction register interfering with that particular clobbered index. Does everything fall apart? Yes, but no. Beautiful. Expected left paren but got comma. That is fine. It thinks clobbers is... yeah. Unknown opcode clobbers. It's just going, hey, I don't know what this is, but I trust you do. Okay. So as soon as we parse clobbers, we should be at a stage where we're actually able to use them. Once however, we also populate hardware registers in this adjacency matrix. So we collect all our v-regs, but we would like to also push all of the hardware registers first. So this is going to change from a vreg vector just to a reg vector. Okay. This is going to be a whole mess. It's going to be like a whole trickle down thing. I don't have the time to do that right now. I wish I did. I am working, just a little update, I'm working on bettering my audio setup. Cheeto Bandito, thank you so much for the follow. What a great name. Oak Spirit, you as well, said who 13. Thank you. Be sure to check out the Discord. Join this amazing group of amazing people, just like Pan has joined. Welcome, Pan. Thanks for joining the Discord. And if Discord isn't your thing, you don't want to be around us losers, that's fine. Go to youtube.com/@LENSR, and you will be met with my glorious voice for hours and hours and hours and hours. The link to the Discord can be found in the About section, which is, if you're on mobile, you gotta do some digging, but it's in the About section, it's there. I still have to work on it. So, yes. I'm gonna look at what that notification is. It's nothing. Twitchbot in Intercept when? Makes me want to cry. I don't even want to think about networking in Intercept. Oh god. I want to get register allocation working first. Like, robustly. Crypto Racer, thank you so much for the follow. Did I already say that? No, I said Cheeto Bandito. That's right. This all virtual registers that need colored. Populate list of registers. First using hardware registers, then using virtual registers. To do virtual register renaming step. We talked about this more as well. Virtual register renaming pass. So basically, yeah, this would become this. So if we have like V10, V37, and V23, but these are the only ones in the program, we should renumber everything to be, okay, this is V1, this is V1 as well, I'm assuming. This is V2 and this is V3. So we just rename them as we go. And that will keep us, well, one, it will allow us to actually just have these numbers be indexes into this list, which means that we don't have to do anything crazy any longer. Yeah, first one should be V1. Awesome. Sword says, if that's really my message, then I made a typo there. I think I did just literally copy and paste, but I may have transcribed it, in which case it's likely me. I would blame myself before I blame you, Sarit. You're much more methodical in your typing than I am. List of all registers that need colored. And then, yeah, first using hard and then using virtual registers. Start renumbering virtual registers starting at the number of available hardware registers. So basically, we'll rename our virtual registers. We could probably do this as we go. We'll think about it. But we rename our virtual registers. If we have, for example, like 10 hardware registers, then we'd start at 10, and then this would be 11, and then this would be 10 again, and this would be 12, right? Because R1, or R0 through R9 is going to be hardware. I don't know. Something to think about. Probably something like that. And that's definitely something we're going to have to do. Yeah, we just need to keep a vector of old value, new value, and then replace. That's probably the best option because that way you can just directly index into the matrix without any index transformations other than making sure it's in the upper lower triangle, whichever one you're using. I think I'm using the lower one. I don't actually know. Let's look at instruction reg or agem set. That'll tell me. Yeah, I'm using the lower one. Because the instruction index is going to be for each instruction, and then when we set the live indices of each one, that means we're going to be going through at the X. Okay. So if I just try and imagine this, we can't assign Rax or RDX to anything here. Which will prevent Rax from being clobbered from here to here. Yes. What happens if I just don't do this? Obviously it's going to work unless everything crashes. I don't handle semicolons well. That's fair. That's fair. Yeah, and it works. Okay. I'm sure if we tried to divide something, it'd freak out, but... do we have a divide test? We have div by 0. We don't really have like a simple divide. Well... Sure. Okay, there you go. Easy. So it's a divide of two immediates, which makes it a little more complicated. Just try the divide by 0 one. What could go wrong? Yeah, sure, why not? Let's do it. We did it! Yeah, so yeah. Bear with me. So that would be register immediate, which we should be able to do. That means we have to move a new temp. Yeah, okay. Dividing immediate sucks because we're actually going to have to move the right-hand side, which is going to be an immediate, right? We're going to have to move the right-hand side into some register. So we're going to have to like move this thing. Let's just do I2 or whatever. We're going to have to move an immediate into I2, and then we're going to have to divide by I2. It's a mess, truthfully. Expected identifier in order to parse opcode. There is an extra match. Beautiful. R0. Nice. Yeah. How'd I screw that one up? What? So move right-hand side in the I2. Move to R1. IDiv R1 8. Move register racks I1. How did that one screw up? Oh, equals racks. Pog. We don't handle it, clearly, so it's not going to be in the object file, but it seems to be working. I mean, there's a bunch of register to register moves and stuff that we got rid of, but it seems to be working. I guess technically we should actually check, like, how would we use something? So this should do a divided by 2, but load 4 first. Is that what will happen? Are we still that? We're not reordering things, right? Where are we at? Things do interfere, so I think we've done something. Move 2 into R1, add 4 into R1, move R1 to R2, move R2 to R1. It's a funky little pattern. And also the div is not printed out because of my stupid terminal bug. I hate that this happens. It's like, oh yeah, just don't print a line. It's so annoying. It makes me want to cry. You can move into a register and generate an MIR div, I think. Wait. And that will then be replaced in turn. That way you don't have that much duplication in the table. Interesting. I didn't think about this possibility. This is kind of hurting my head. Yeah, because we can continue expansion. So this left-hand side racks could go div right-hand side move. Can just be this thing, but with I2. Yeah? Is that gonna do anything? That does the same thing, so you've done it properly. Somehow we still get move R0 after IDiv. Because I did the same thing! Ugh. Macro expansion go burr. That's right. Really wish it would print out that divide instruction. Jeez. Anywho, it's looking pretty good other than this ridiculousness, right? Why is there an interference? Go, IDiv, move, add, move, move. So we move A into V2, move 2 into V7. We move V2 to R1. What is that for? Load A integer. Okay, that's fair. So we load A into racks and 2 into V7, some temporary. And then we divide, we divide by 2. And then we move racks into V4. V4 is the result of our division. and then we add 4 to the result of our division. We move the result of our division into v5, and then we move v5 into r1. What is this? Oh, because we have an add and return. So when we add an immediate to register, and that register is racks, so yeah, if we add 4 into v4, what's our input here? We have add 4 into register, return that result. So once we can compare operands with is, we will be able to have a return with a v5 that is the result of an add immediate to register, which will mean that we can reduce all of this to just add into racks. Okay. We are slowly getting more and more complicated instruction selection working. I really like that that style of macro expansion. That's pretty poggers. So do you think I could do that for anything with these immediate things? Because, for example, add immediate, I guess it wouldn't matter because it's still just 2 lines. And we don't need to have this move. Yeah, when we already know it's there. Okay. So add is a little bit different because they are actually different. Whereas with divide, we do just want this exact stuff. Cool. Can do the same thing for mod then. Where we have register divided by immediate. How I did it, right? Yes. And then we would like to actually just replace this with an MIR mod after moving. Coolio. There's definitely is some more code duplication that you could get rid of probably, but I know the best way of doing that would be something like the macro system that I used in my version. Yeah, something like that. I was also thinking about like allowing like sets of things. So you could have a set of opcodes, like you're in braces and you do MX64 test, MX64 compare. You know what I mean? Like it's one of those. Obviously, those would only be allowed in certain cases, like in pattern matching, because you'd have like immediate register cond, but that would make everything really complicated because every permutation of all the different sets in each pattern would have to be tested. Or you could just say, for the first operand, is it immediate? Is it a register? If so, move on. There's a lot of ways to do it, but I've been thinking about it. The macro system is clean because it's just so simple. For immediate register T, right? Like if we just did some syntax like this, it would make it so much more simple for something that works with both immediate and registers. Or for both branch and branch conditional, but it's complicated. I like the Lexing level of macro. That might be a good idea. Okay, everybody, thank you so much for watching. Thank you for the raid today from her Hotson plots. That's right. That was incredible. And I'm excited to actually get this clobbers stuff working. There's so much to do at this point, and I am excited to do it. I wish I had more time. Taxborn says, thanks for the stream. Thank you for watching. It's no fun to just sit here alone. So you guys really make this worth it, in my eyes. But yeah, we've got the clobbers thing. I might work on that off stream, but I will do my best to work on everything on stream. So yeah, we'll definitely be back here. So stay tuned. If you want to be notified every single time I go live, be sure to join the Discord. There's an announcements channel where, look, I make an announcement every time I go live. You can ask to join the notifs group, get the notifs role, I'll assign it to you, and then ping, I'm live, right? Or if you're not really into catching this live stuff all the time and want to like, oh, he's live, go watch. Again, go to youtube.com/@lensr /@lenser. I did youtube.com, which one will not work. But if you do type in the proper address, you'll find my YouTube channel with all of my VODs. Lots of VODs. Lots of long compiler VODs. So be sure to check it out. I really recommend it. Thank you so much for watching. I am excited to continue working on all of this stuff with you. And we need to get ready. Why is this lower than it is normally? What you need to work on off stream is fixing indentation in the doc's eyes. That's right. That's right. I will actually try and do that. So if I don't indent first, that means I have to go through after every figure and then add, yeah, add no indent. Okay. I wonder if I could make it a part of the float barrier. I wonder if I could just make this a new environment, like my figure. Okay, I'll think about it. I'll think about it. Thank you, everybody, so much for watching. I've had a great time today. I want to see you next time, so join that Discord, click that button, do that thing. Taxborn, you are now notification friendly. Welcome to the Notifs group. Thanks for joining. Be sure to join anything that you would like to. Stay tuned, check out the GitHub Discord, make pull requests, and most importantly, be awesome, make your awesome programs. You are an awesome programmer. You're going to make cool things, and I want to see it. Share it with me. Show me in the Discord. Do it! All right, I'll see you next time. Bye, everybody.